Okay, just give me 1 second, okay? Okay. So good evening, everyone. This is first session for week 5, but we will be discussing project exclusively today. I've noticed that a lot of you have joined. GA5 deadline, we're in discussions of moving the deadline, but we don't know exactly at the moment to what date we are going to fix it to. But it will not be this weekend. That much I can assure you. So that's so that you can have some bit of extra time to do focus just on project 1, and also because we can't cover the content of week 5 this week. So today's session, tomorrow's session, day after session, all 3 sessions will be focused on project 1. If you're done week 1 through week 3 well, then you should be well on your way with regards to being able to solve it. What we will do today is go through the steps required in order for you to execute on it, and so I will be taking you through that process. Our goal today will be to get now. So for some of you, this might be very straightforward, and you already know how to do this. But we get a lot. We got a lot of private messages, emails, and things like that, other than discourse, where students have said, you need to help us with these basic things. So what we'll do is we'll take you through the basic steps, okay? And for some of you that may not be necessary, but you'll have to bear with us because we're trying to get everyone to at least submit a project, right? To get to the point to submitting a project. So we'll take you through the basic steps. Some of it may be too easy for you today, but we will then, once we so first part is getting GitHub sorted, pushing code to it, writing some code which will be running at least task A1 on your project. And the reason we say at least task A1 is because without running task A1, you will fail your project anyway, right? So if you can't get task A1 to run, you cannot run the rest of your project. So we will get you to task A1, and then we will give you some code, a code skeleton to get you working on other tasks as well. So with that minimal structure, then at least you should be able to execute on the rest of it, because then it's kind of, I won't say copy paste, but it is just making some alterations in your code to run the rest of the task. So this is the goal. Will we cover everything today? I'm not 100% certain, but we will try to at least get you to task A1 today. Does that sound like a plan that works for you guys? Okay. Right. So if you, let's see. Starting and ending steps as well. Yeah. So what do you mean by that, Anand? Can you just clarify a little bit for me? Steps related, yeah, we will do that as well. It's on our agenda for today. Yeah, we will talk about that as well, the evaluation, how it works. Okay, I'm just waiting on getting this up and running here. Have you put the markdown file in? Markdown file. Right. Okay, got it. Okay. Go to the drive here. Hi, Ripsudin, are you a student in the TDS course? Ripsudan Kumar, are you a TDS student? Am I audible?
Yes, sir, you're audible.
Uh, Hang on, I'm just trying to pull a file here. Okay, just give me 1 second. And 5 days, no project. Markdown. Where is the markdown? Is this the markdown? Is it? No. Oh, there it is. Yeah, got it. Got it. To share my screen. Okay, is my screen visible? Okay. What I was trying to do is get a clean VM running so that we can kind of show you everything from the start. That's why there was a little bit of a delay in getting this session started. I'm not entirely sure this VM is working correctly, but we will see. In part B as well. So today we might not get to part B. Okay, if we can get at least to getting to task A1, then that would be, I would say, something that we are trying to get to today. There's a session tomorrow and there's a third session. So we will be discussing project all through this week. So don't worry about task B. Yeah, Kumar, just
Sir,
open your mic and ask. Yeah.
sir, is this session recorded and available on YouTube also so that we can watch it later?
Yeah, it will be recorded and available on YouTube. But the only thing is you won't be able to ask questions on YouTube, right? So,
Okay, sir. Okay.
so that's the only thing.
I,
That's the downside. Okay.
okay, sir. Sir, actually, I am working on my project, sir, and I had generated data folder as the way you explain on the Git and uh, on Discourse portal.
Yeah.
So right now, I'm currently encountering an issue like how can I verify if I am defining the task correct or not, sir? Like how can I verify that with the help of evaluate.py file?
Okay. So just a caveat before I start. Okay. I've
Okay, sir. Okay,
created.
sir.
So this what you're seeing on the screen is a VM. Okay. I'm actually running
Okay, sir.
inside a VM. I haven't verified that this VM works. Okay. So there might be some issues today, but we'll
Okay, sir.
hopefully there won't be any issues. We will try and see. Okay.
Okay, sir.
So let me just get the session started anyway.
Sure,
So
sir.
as you
Thank
know,
you.
there are a few deliverables that are absolutely required with regards to project, and the first thing is you have to create a GitHub repository. So so there are 54 people of you here. Can you raise your hands if you don't know how to do a GitHub repository? Okay, Rishit. Anyone else? Okay, so the rest of you all know how to get a GitHub repository running, right? Now, for the sake of Rishit and also people who are going to be watching this session later, I will just briefly go through how it's done, okay? So effectively, Rishit, you will have to open your mic and respond, okay? The first thing is, do you know how to get to GitHub and create a new repository through the site? You'll have to
So
open your
I've
mic.
just created the repository.
Okay, you have created one on GitHub.
Yeah. Yes,
Okay,
sir.
okay. So the next step is you have to add an MIT license to it. Do you know how to do that?
No, sir.
Okay. Normally, when you create a repository, so I'm going to use this as an example. Okay. Uh, Normally, when you create a repository, there should be a files setting where it allows you to add it. It's typically when you create it itself. Uh, Why is this not scrolling? That's what I'm trying to scroll. Okay, that's weird. That's not scrolling. Strange. Okay. Let's reopen this again. Okay. Okay, it's working. Right. So, actually, I'm not sure where the. Typically, what happens is we get. Okay, I don't know why my mouse is not working. That's very weird. There we go. Typically, so usually when we create it itself, we are able to put a license file. So maybe I can just create one.
So can we go through the step one?
Yeah,
Maybe might be
that's
helpful.
why. Yeah. So what
Like
I'll do is
creating
I'll
that
just.
approach.
Yeah, I think I'll just create one. That's just the easiest thing to do. So. Okay, so when you log into your GitHub, right, you can just create a new repository. Okay, it says new, put a name. So we'll say TDS, today's Tuesday session. I'll call it TDS Tuesday. And then you can choose it to be public or private. For today's demonstration, we can try to make it private because then I can show you how to put a token and get the token to access your repository. So that way your repository can remain private. But one thing to remember is if you make it private, don't forget to make it public before submission. If you don't do that, you will not pass the project. Okay, so just keep that in mind. But I'll show you how to create a private one today because it's a little more involved. And then you can ignore this add a readme file. But you see over here where it says choose a license. So this is where you say select and you say you have to use this license, okay, MIT license.
Sir, can you
Okay.
tell me the purpose of this?
The purpose of this, in order to pass project, you need to do it.
No, the purpose of
Uh,
MIT license. What is
oh,
it?
the purpose of the license. Okay, so different licenses, right, allow someone else who looks at your code. It tells them what they can and cannot do with your code. So if, say, for
All right.
example, if you use a closed license, okay, here there are no closed licenses, but let's say you don't want anyone to commercially use your software and make money from your software, then you have to give it a different license term. Your solicitor or someone who deals with IP protection, they are the people who will be able to advise you what kind of commercial licenses are available. The licenses available here are generally public licenses, but there are different types of public licenses. So the most common one is this GNU, which is General Public License, or Apache license, or MIT. These are the most common ones that are usually used. MIT is usually used in education circles. GNU is generally used for open source software, and so is Apache. There are slight differences. It's not worth me discussing that what the differences are today, and I'm not a legal expert on what the clauses are. You can always look that up. But these are the purposes of license. And for the project, you are required to use this one. Okay, don't use any other license. So if you don't have these deliverables, right, you will not. These are like your minimum requirements. You must have this. You see here it says prerequisites must be followed for you to be eligible for evaluation. So you will not even be evaluated if these are not present. So just remember that. Yes, Sakshi.
Sir, actually, I want to ask if is it okay if we initially take repository to be public?
Yeah, you can. Yeah, you can. There's no issues with that. I'm just showing private today because some of you may want to do it privately, and then. But the important thing to remember is, if you look here, this is a requirement. It has to be public. Okay, so you can change it to a public repository later, but don't forget to do it. So I'll make it private today, and then later I'll show you how to get it back to public.
Okay,
The,
sir.
re the repo is created. Click on add file. To create a new. Abhijit, you're saying to create a new license, is it? Fantastic. That's a great suggestion. Thanks, Abhijit. So, but if you're creating it for the first time, this is how you do it. You can select over here what you want. Don't worry about a README file or Git ignore. Just make sure that there's an MIT license. You click create repository and it creates it. We'll also try Abhijit's route just to see if that works. So I was working on, let's see more. It was called TDS project. No, that's not the one. Where is it? I have lost track of it. Tools, TDS. Oh my. Let me.
You reload it, becomes visible.
Yeah, here it is. This one. Okay, so the other way is Abhijit's suggestion, which is go say add file, create new file. So this and then where is what is it? Create new file in file name type license. Okay, so we'll type license. Oh, choose a license template. Oh, that's fantastic. That's pretty convenient. So as soon as you type license, this will pop up over here saying choose a type license template. So if you've already got a repository, this is how you can add a license to it. Okay, say okay, and then you can select one of these. We'll say MIT and adopt, say review and submit, and then it's created the license. So if you go back here, you can see that it has added the license file. So that's a fantastic suggestion. So that's how you create a license if you already got one. Okay, everyone's fine with it so far, right? Yes. Okay, great. Right. The next thing is we need to look at our list of things that I need to go through. Okay, allow. Right. So the next thing we need to do is configure Git on our system. Okay, so if I open up, so I presume that most of you are working in WSL for the purposes of this demonstration. Okay, I'm not going to show you how to run or create WSL, but there are some simple commands you can run in your shell. So if I go PowerShell, Okay, if you type WSL -- I think it's install. Okay, I know it says the name of the WSL, but if you have not installed WSL at all, let's see here. If you have not installed it at all, then you only use this. Okay, and once it runs through this command, don't worry about this. Okay, just if you run WSL -- install, once it completes, you have to restart your system. Okay, and once you restart your system, you can verify that it is installed correctly. You just put -L -V. Oops, -V. Okay, and then it will tell you if it's been installed and what's running on it and all that sort of thing. Okay, so that's then the next thing you want to do is, after WSL is installed, you want to install a particular version, so like Ubuntu or something like that. Then what you do is you say WSL install and the distribution name that you want to give it. So I would recommend this one, 2404, because it's a very stable long LTS version. So LTS means long-term support. It's usually for corporations, so it means there are very less bugs in it. Okay, so the code is tested before it's been put out. So use this, I would say. So what you would do is you would say WSL. This is after you restart your system. Okay, you would say install and you would give this. Why do I keep losing my mouse? Okay, you use WSL and you say -- install and you give it this name and it will run it. I'm not going to do this now because it's already installed and it takes a long time. So that's not what I'm going to show you. But that's how
Could
you
you share
install
the
it.
link for this text file?
This one, right?
Learn.microsoft.
Yeah,
Yes, sir.
I can stick it in the browser here for you.
Sir, why do we need WSL?
Because first of all, it's a separate environment from the rest of your system. So if anything messes up, it's not going to destroy your system. So that's the great value about it. And almost everything that we do, right? Most of the packages we run typically run through Linux, and they run well on Linux. That does not mean you can't do it in Windows. You can, but the way you do it through there might be a bit different. So that's why I'm showing you through WSL. Okay, but that's the assumption. That's the assumption I'm making. Okay, so once that's ready
Sir, we
to
can
run,
use VS Code. We can give commands on WSL using VS Code as well.
yeah, you can do. So that's what I'll show you next. If I do, so if you want to, so next thing is, of course, you should have VS Code on your system, and I've just installed VS Code on here. And then the extension that you would need is called WSL, and you can see this, right? WSL install. So install this extension. Okay, you go to extensions in VS Code and say install. Okay, and that should be done. All right, the next thing is, if I believe I can just type dot code over here. It should, oops. Okay, just give me a couple of minutes here. Sorry. Today's session might run a little long. Okay, I hope you guys don't mind. If you're using Mac, it's no problem. You don't need to worry about running Linux commands on Mac. Mac natively supports most Linux commands without any issues. And in fact, I'm running this Windows VM on my Mac. Okay. So if you've noticed, now if you notice the difference between these two VS codes. So this first VS code, if I put this on there. This, come on. Oops. Okay, if you look at the difference between these two, okay, this I ran from within WSL. Okay, I typed this word code and it launched the VS Code, and it launched this window over here. And if you look over here carefully at the bottom, it says WSL Ubuntu 24.04. This is running inside your WSL, inside your Linux machine. This one is running on Windows, and that's why you can see over here it doesn't have this indication over here. Okay, so we will be running this one. So if I say open a folder, and in fact, and it'll show you these folders, and these are inside the Linux machine. So if I open actually the terminal, which is control, yeah, you notice it's got this kind of a terminal because this is inside the Linux machine. See, this is inside the Linux machine. So that's why whatever we do now will be running from inside this Linux machine. So that's the next thing. Okay, the next item on the agenda is, once we got that running, where is my next thing? Okay, so next I've got to show you how to, so you'll write some code, you have to push it to GitHub. So if you look at one of the requirements of the project, right, is you have to commit and push your code to GitHub. Okay, that is a requirement. Where is it? Evaluation. Yeah. GitHub repository access post. Yeah. So you'll have to push your Dockerfile basically to GitHub repository. Okay. So we'll just make write a little bit of code and push it now. Okay. Oh, actually, before we push that code, we have to initialize your GitHub repository. So the folder I'm working in right now is just my home folder. And so we can just make a directory and call it TDS Tuesday. Okay. And then make this a bit bigger. Okay. So the next step is to start. So inside your computer is WSL will have its own Git. I think it does anyway. Let's just make sure. Yeah. Okay. So yeah. So when you install WSL and particularly Ubuntu, it comes with Git already part of the package. Okay. So this Git is different from GitHub. Okay. This Git is a package that keeps versions of your code locally on your system, but you need to connect this to GitHub. You need to push code to GitHub, which is online, right? So first what you do is you do git init, which initialize the repo. So that's what it's done here. And then the next thing is we need to add that repo that you have created on GitHub to your local machine. Okay. But before we do that, we also need to configure Git so that it works correctly. Okay. So for that, we need to use this command called git config -- global user.name. Okay, and then you put your name, and then you say git config global. If you don't do this, by the way, it will not work correctly. Your GitHub, your Git repo. Okay, when you're trying to push commits and things of that sort. Okay, so these two commands, one is your username you have to set, and one is the user email. You have to configure this, and then your Git is ready to start adding repos to it and pushing code to it. So next thing is we will add this what we call the remote repo. So this is the remote repo because this is not local, so it's somewhere away from your system, right? So it's called a remote repo. And if you go to this button called code, you can see this URL here. right? You can copy this URL. So there's a little copy button here. Go back to your terminal over here, and then just
Sir,
paste it.
just one thing in
Yeah,
Git, in global user dot name, you have mentioned the name, but
yes.
in the Chrome, your GitHub username was different. So is it will work for different username as well?
Yeah, so this Git, right, this is specific to your local machine here, but you have to configure this, because whenever you push something to your remote repo, right, it needs to know who has sent it. So it will just say Carlton has sent it. It could be someone else also, right? So you could have a team working on it. So you could have Jivraj or you could have Saranj, and they all need to be identified. So that's why you need this username. So because so that you can identify who is pushing what. Okay. Hello.
Yes.
Okay. Yeah. All right. So after this is configured, now we can do git remote add, and you have to put the repo name here, right? So you do. Okay. And so you put the repo name here, and then not the URL, the repo name. So in this case, we'll call it TDS Tuesday or something. Okay, repo name and then the URL name. This is just to identify it, and this is the URL of the repo. Now
No,
I
sir.
suspect this is.
Oh, yeah,
Yes.
that's a different URL. It's for TDS Jan 25. The
Yeah,
repo,
that's okay.
yeah, sure.
Yeah, that's okay. We have. I mean, it's to demonstrate how to add your URL, right? So you just put the URL and put the name of the repo. Okay, this is your local name of the repo. This is the remote repo you're trying to add.
Okay, okay, okay.
Okay. So let's see. I think it will not work because I think it's because it's private, but we'll see. Oh, it added it. Okay, fine. Maybe this one is public. I'm not sure. I don't remember. Let's have a look. So then we need to pull some code. So git pull TDS Tuesday, and I think it's called main branch, right? Okay, so it'll ask you to sign in, and then we just have to sign in over here. This is the advantage of doing this via VS Code, by the way. You don't have to worry about tokens, I think. I think you're able to just authenticate this way. Why did this not work? Big room. That's correct. Just give me 1 second. Might be on here. Just 1 second. GitHub. That's the one. Yeah. Okay. Yes, update. Okay. Use authenticator app. So I've got two-factor authentication. So just give me 1 second. Okay. Great. So you notice I didn't even have to get the tokens or things of that sort, because we have installed the extensions, and we've installed running this through VS Code. It plays nicely with GitHub. Okay, so that's one advantage of doing it this way. Right, another extension that might be worth doing then is called GitHub Git extension. I'm sure. Let's see. Git. Actually, it was in the recommended. Now, typically, I have all these already installed on my system, but I'm doing this on a Windows VM for your benefit, so that you can.
So could you just specify all the required extensions to be installed in VS Code?
Yeah. I'm just. The GitHub. Okay, let me check on my system. Okay, hang on. Extensions. What do I have here? Actually, I think it's already natively part of VS Code. Let's have a look. Yeah, you don't have to install a GitHub extension. It's natively part of VS Code. So if you go to source control over here, the file we just pulled, yeah, you can see that it already gets the folder and the license. So you can see this, right? So it has already done that, which is very nice. That's Tuesday. Yeah. So that's the workflow for getting your GitHub linked to your place where you're working on your code. Okay. So the next thing we want to do is we want to so we'll start creating an application. We'll call it app.py. Okay. And let me just grab some code over here that's been made already. Oh. Okay. Yeah, just open your mic and speak, because I can't see the screen at the moment. What if you have raised your hand or something? Or
Sir, I've raised it. Sir, just one question. Whenever we'll type code on WSL terminal
yeah,
for system, every time the window for VS Code which will open is every time is new, or the one which we are working in
you'll
before.
have to repeat that question again. Just say that again, please.
Sir, whenever we type code on the terminal, the
Hmm.
window which will open, VS Code window would open. Do this window is every time new, or it will the previous one?
I still didn't understand the question. Did someone else understand what who's speaking? Sorry.
Sir, Sakshi, actually,
Sakshi. Hmm.
yes, sir. Sir, I'm asking that you type code on WSL terminal to open
Yeah.
this
Code.
VS Code.
This VS Code. Yeah.
Yes,
Understood.
sir.
Okay.
So
So you're
so do
saying, so if I just close this, for example, right? If
yes, sir.
I close all this. Yeah, let me close all this. Okay. So you're saying on this terminal, if I type code,
Yes, sir.
it will open exactly where we were working before.
Okay, sir. That's what I'm asking. Okay,
Yeah.
thank you, sir.
Yeah. Okay. In fact, what we can do, I'll just close this, go one step down, type code here and see what happens. Yeah, it just opens to the previous one that it was working on. Okay.
Thank you, sir.
All right. Okay. Meanwhile, okay. So the first thing, okay, let's have a look back at our project one. So we've got Okay. Okay, so we need to create some little code that we can push into Docker, right? Pushing code, by the way, is also straightforward from WSL. So let's say we've created an app.file and
Excuse me, sir.
yeah.
Yeah, are you live streaming this session?
No, it's not live streamed. It's being recorded.
So, will you share this later on for our
Yes,
reference?
typically it'll come tomorrow morning.
Okay, sir. Thank you. Thank you so much.
Yeah. Okay. So this, so let's say we create this file. This is the project file. Okay. And now we want to push this. So you see it turned to green and it says you. So what that means is it's been modified, and pushing to GitHub is just as simple as saying you need to put a message here. So created app. Okay, it could be anything. It doesn't have to be, but just for your reference, and just say commit, and then say yes, and then publish, and it's done. Okay, that's it. That's all you have to do to push code. If you're doing it via terminal, then you would have to use so share the command for you for that. It's git push. Okay, so before we pulled code, remember, so we pulled code from the remote server. Now we're pushing it to the remote server. So TDS Tuesday we called it. Okay, and which branch? We'll say main branch. Oh, oh yeah, we are not in the correct folder. TDS Tuesday. Failed to push. Doesn't match any. Maybe it's not called main. It's called master. Okay. Right. So then. I have to do this again. Right. I think here most likely I have to give a token. Most likely, but we'll see. Yes. Okay. So you see the difference now, right? So I've tried to push it from terminal, but it failed because GitHub does no longer accepts taking passwords through here. It only, if you did it through VS Code, it opened up authentication window in the browser, and it accepts authentication through the browser. But if you push it through your terminal, it will not accept passwords and usernames. You have to put a username, but you'll have to get a token. And to get a token from GitHub, you'd have to go here and say, I believe it was under settings. And then if you go to the bottom here, developer settings, and then here you get personal access tokens. You can go classic tokens, and then you can say generate new token. You can generate a classic token. Okay, it's asking for authentication, so I'd have to do that again. But basically, it's a long, convoluted process, right? So to avoid all this, you can just use VS Code to connect to GitHub, and it's just simpler. 3, 0, 8. Right, and then we can say TDS Tuesday token, and then you have to tell what permissions you want to give this token. So I'll just, for now, just put all this and say, yeah, I want all the permissions. Typically, you just read through these, okay, and decide what is appropriate and what's not appropriate. But just to avoid any complications for today. Okay, so generate token, and you get a token here. You can see this right over here. So you copy this, and once you go away from this page, you'll never see this token again. It's lost forever, or you'll just have to generate a new token. Okay, so you can see, make sure you copy this token. You won't be able to see it again. So we copied this token, go straight back here, and we go git push, and we use put the username, and we paste our token in here. Ta-da! It works now. But it was a lot more convoluted, right? So, but I've shown you both ways. In case you're on a different machine, you're not using VS Code, you're using, I don't know, Eclipse or Idle or some other IDE, you can at least know how Git works. So you know completely how Git works now. So let's move on to the next thing. Any questions so far? Everything's fine, right? I know it's a bit fast, but hopefully it's clear. Anyone who didn't understand what was going on? Okay. Okay, great. So I just verify that this is worked as expected. So I go GitHub. And we look at TDS Jan. And I thought okay, right, never mind. It was main branch, but I pushed something onto master branch, okay. So now there are actually 2 branches, but I should have actually pushed to main. So yeah, okay, right. I'm going to delete this one. That's the active branch. Right. Default active. Okay, right. I think we are now on this branch, right? Only main. Yes. Okay, let's try and push back to this branch. This is interesting. I don't know why this says master. That's okay. We'll not worry about this now, but typically, okay, we'll not worry about that now. But keep it consistent. Whatever branch you're pushing to, keep it consistent. And just like I said, if you use VS Code, then you don't have to worry too much about branching and things of that sort. Right. Now, the very first thing is we have got to get a server running, okay? A server that delivers endpoints. So that's what we're going to do next. We do script. So anyone knows what I'm doing now? You can open your mic and talk.
3 UV.
Yep, that's exactly right. I'm putting UV. So UV requires metadata. Let me remove this bit over here.
Question here, Carlton.
Yeah.
So the question here is, in order to, like, for example, we are mentioning these requirements which should be done, like whatever the project requirement will be there, it will be completed by UV. So my question is, for example, if we are doing these things, we need to run the UV, like we need to run this script in the UV environment, if my understanding is correct. Is there something like that?
Yes. So the script you're running, okay. So before I get to that, your question, right now what I'm going to do is, the reason I'm showing you this now is, in your project, you're going to be delivering a server, okay. That's effectively your goal, okay. What does this server do? It responds to 2 endpoints, okay. One endpoint is, can those of you who have worked on the project, can you tell me what the one endpoint is?
One endpoint will receive the query from the user, and another will fetch the file from the backend and deliver.
Correct. So there are 2 endpoints, and if we go, thanks for that. Who was that?
Avnish.
Okay, thanks, Avnish. So there are 2 endpoints that your server has to respond to. Okay, and you can see that over here. Actually, in fact, you can see it in evaluation. So one is this endpoint, right? And the other is this endpoint. So that's what we got to create. But how does this server run? You needed to run this Python file that we're creating. The Python file will create this server that is going to deliver these endpoints. The technology we're going to use to run the Python file is called UV. Why? Because UV is able to, without pip installing and doing all these sorts of things, UV is a complete package manager. It's able to take a Python file, it's able to look at the dependencies, get the dependencies, install the dependencies, create the virtual environment, launch the server. It's able to do all these things. So that's why we use UV, because it's a fantastic package manager, right? There's no
Is it
manual.
available in VS Code?
Sorry?
Is it available in VS Code?
It's not. VS Code is just this is only an IDE, what we call an IDE. It's a integrated developer environment. This is just to edit files. It's basically a glorified text editor. That's what VS Code is. It has some extensions that makes it useful, but that's all it is. Okay, but UV itself is a package that is a package that manages Python dependencies and Python files. So in order to install UV, we have to pip install it. So pip install UV, because I don't think we have UV installed on here. All right, I need to install Python 3 as well. Python pip, yeah. Okay. Sudo install. So the reason why these are not on the system is because this is a clean, fresh system. Okay, so that I can show you these things from scratch. I'm just hoping everything.
Sir, so UV is compulsory, like in every code we should.
Yeah, you will need UV in order to not only run your server,
Yeah,
but in order
that I can understand, sir. But say we are doing some other way like Flask. Flask also we can use UV, but the thing is, if we are like importing everything in a Python file.
Yeah.
Can we do like that, or we should do UV compulsory?
See, the reason to have UV on the system, right, in your, oh, I think we'll have some problem. Okay. Anyway, so the reason why it's important to have UV on the system, okay, because this is what will eventually get put on your Docker image, okay. So if your code doesn't know how to use UV, then you could, in theory, write your server to launch a Flask server. You could do that. But then what will happen is the evaluate PY is going to send some code, okay? Send some tasks to your application. Those tasks will not run unless UV is running.
Okay.
Do you see the problem?
Okay.
Right?
Okay.
It won't be able to automate the code that is being generated, because your server will generate some of its own unique code, right, through the LLM or through some function calls. It will generate something, and in order to run those tasks or that code that you have not written but the LLM has written, how will it run it? We might need to pip install, or it might need to create a virtual environment, or any number of dependencies might be there. And the other problem is, if you pip install things and run them, these sublet codes or these small little micro codes that are generated, it may corrupt the rest of your system, right? But then your tasks that you're running in the future are not going to work, right? Because you don't know what the code is doing. But the beauty of UV is it will run the code, and whatever happens, at the end of the day, it will, once it stops functioning, it disposes of the virtual environment it created. It's a complete package manager. Do you see what I mean?
Okay.
Once the code stops running, UV disposes of the virtual environment that it created to run that piece of code. So whatever dependencies it fetched also, it will just get rid of them. So anytime you run another UV task, it will again get either from its cache or either from the internet. It will grab the fresh dependencies, and it will then use the code, package it together, run it. Once it finishes execution, it will dispose of it. So that's what you will do.
Yes.
Okay.
Okay.
Yeah. Now I think we will have a problem because for some reason this WSL package that I installed earlier, which I didn't have time to test, there was some error with this DPKG application. So I am not 100% sure UV will run or not. But if it doesn't, I'll just send this code over to Jivraj, who's in the session, and then he can run it on his system, or I can. Yeah, no, he will be able to run it on his system. Okay. I apologize for this, that we didn't have this virtual environment ready in time, but we'll see how it goes. Okay.
Carlton, I have one more question to ask, if you may
Yeah.
allow.
Yeah.
So what I was asking for asking is, for
Yeah.
example, like I'm working on my system.
Yeah.
Okay, and do we need to create an virtual environment using the UV?
You don't have to create any virtual environment. UV takes care of it all.
So what my understanding is, I just have to create this script file, and in the terminal I just have to install the UV, and
Yes.
from there onwards, if anything is written there under that markdown, that will be installed. That will be the responsibility of UV.
Yes.
And every time, if for example, if I've done half the things, then I'm opening that thing in that particular folder, the UV will still be there. I need not to run it once again.
Yeah. Yeah.
Okay.
Yeah. Okay. Right. Let's. Okay. So in order to create a basic server which responds to endpoints, so okay, and then we'll have to. So we create a fast API object. We will need to make sure that it can get requests. Oops, we can get requests from anywhere. So we'll do app.add middleware. So this enables it to get cross-domain requests, because we don't know what the tasks will require. And so this over here, you need to be tell it what methods are allowed. Okay, so there's the get method for get requests, and there's the post method for post requests. Hopefully, I don't have to explain what these are. Do we want delete? No, I don't think we want delete. Yeah, just get and post requests. Okay, and then allow headers, and then we want headers from any location. Okay, so this allows headers, and this allows from all origins. And what else? This commas here. Yeah. Okay, that's fine. Okay, so that's that, and then we need to check if our server is running. So I usually like to have a dummy endpoint which tells if our server is running. So it's easy to know if the connectivity is correct. So this is something most students forget, okay? But this is actually a great thing to have. They straight away go working on some complex solution without just checking basic connectivity. So, and all this will return is, yay, TDS Tuesday is awesome. Okay, right, that's all it will return. And Then if so one thing is I'm not getting what you call for that AI assistance because I haven't installed the extension for it. So, but if you've installed, I think it's GitHub Copilot and Codium. These two, I would recommend Codium over GitHub Pilot. It's very, very good. So it's CODEIUM, is it? CODIUM, I think it's called. We'll just double check it here. But it's very worth it, okay? If you guys don't know about this, it's super, super awesome. Codium. So there's a fake one and there's a real one. Okay, maybe it's not. Let's try that one. This is the one. Okay, so don't put CODIUM, okay? It's CODEIUM. That's the correct one. So 2.2 million users, 5 stars. I mean, that's amazing. Okay. UVcorn. So UVcorn is the server that will launch the fast API app. So what's happening here is we're launching this app. It will at the moment only respond to this particular endpoint, which is just the home endpoint. And we are telling what address to run this server on. And we are putting this server on 0000. If you don't know anything about IP addresses, this particular IP address means it is available to anyone on your local machine. Okay. So then we give it a port number and it will run on port 8000. So it will respond to anyone on this machine and it will respond to this particular port 8000. Okay. So I think we are done getting a basic server running, which is good. Now let's test this, shall we? So control. Now this part I'm not sure is going to run. The main reason is I'm not sure that the WSL has worked correctly because when I was installing UV, some errors cropped up. So I have a suspicion this is not going to work. So the command for running UV is UV run, and I believe the file name app.py, and then
Sir, it's app:app.
Sorry.
UV run app: then app. Because
no, that's for UVCon, right?
yeah.
But
Yeah.
sir is running UV.
Yeah, I'm running UV. Yeah, it's just UV run app.py. But the problem is it doesn't install correctly on here. So what I'll do is I think Jivraj will take over at the moment because this VM that I installed has some errors on it. So I can't demonstrate this here. I'll push this file across to Jivraj and then he'll be able to run it. So just give us a second here. File upload. This one I did not know. Could not really relate this one. This was no, that's not it. Yes, but I could relate this. Okay, that's weird. I took the help of Ashwarya as well. Yeah. So over here, right? This is over here. I started from here. Okay. Right. No, it's. Ooh. Let me just rename this. Sorry. I wrote all of this, like I took all of this and tried to take it some R let's say language and R results. And then I saw what they had done on the website. I did the exact same. Okay, that's better. Matrices comparison. And I did not really understand what they did over there. Right? Okay, so I did not do that. And okay, so Jivraj will take over from here and run the file, okay, and demonstrate it for you. Sure. So while he's just getting his system up and running, okay. Yeah, you got it. Yeah, okay, that's fine. So while he's just getting ready to run that file, you guys have any questions meanwhile? Because the next step will be once he gets the server running, we're going to push this image. No, we're going to create a Docker image. We're going to push the Docker image onto Docker Hub. We're going to pull that image back, and then we're going to run that Docker image. So that will be the next steps.
So can we complete A1 task?
Yeah, we will complete A1 as well.
Yeah.
A1 is
Sir,
yeah.
Sir, how much time it will take to complete this project? A rough figure.
Totally dependent on you, brother. I cannot say how much time it will take, right?
Okay.
I mean, if you're good at function calling and working with LLMs, then it will take you maybe a day, I would say, or 2 days. Yes, Kelvin, go ahead.
Yeah, last time, can you show me how to code the LLM effectively?
How to? Yeah, we will do that as well.
Okay, okay.
Yeah. Okay. Meanwhile, while he's getting it up and ready, the let me have a look at our to-do list today. Right. Yeah. So once we get the server running, we will show you how to create the pod and upload and pull the pod. Then the next aspect of it will be creating the API call to run task A1, which is running the datagen.py. So before he codes that, I'll explain what that is, and I'll explain what evaluate.py does, and then we will show you how to code at least A1, so that you're aware of how to get to the first step. Because without running task A1, you won't be able to run any other tasks. Okay, so he's ready, and he will take over from here.
Okay, so Carlton have already created this application. Am I audible? Okay, so I will just execute it. Run DUI.
It will be pretty easy to, let's say, yeah.
Okay, I think we'll need to import it.
App distance, no, that's right.
I don't remember the imports. Integration, fast API.
Alright, so like you can try using the prompts. So like I usually, yes, sir, you can use this prompt.
Jivraj, are you trying to integrate cars in this?
Yeah.
Sure, sir. No,
I'll send you the code. Wait,
sir.
I'm sending it on chat.
Okay. I think now we have integrated codes. So let's try to run it again. Name unicorn is unicorn. Okay.
Oh, sure.
Okay, now this application is running, so let's check if we are able to access it through localhost or not.
Sure.
And it's running on 8000.
Alright. See you then. Good night. Take care of yourself. Bye.
Yeah, so now it is accessible through browser. Okay. Okay, so now what I will be doing, I will be putting this code to something called Dockerfile that will create a Docker image which can be pushed to Docker Hub, and then later it can be pulled from Docker Hub. So Docker is basically a repository similar to GitHub, but instead of we will be having a whole image, so you just pull it and execute it. Is this correct name? So what are the things that we need to install? Basically, in order to run this application for project one, we need Python to be installed in our container, and we also need UV to be installed. So I will just type UV Docker, and I will go over here. So this code, it will get Python from this particular image that might be on Docker Hub or some other repository, and then it will run some commands to install UV, and at the end it will create some binaries. So once we have UV and Python both installed, what is the other task that we want to do? We actually want to put this.
Can you tell us where, like, tell me where you have sourced all these things from, like the file which is there?
So I have got it from the UV official documentation. So just typed UV space Docker, and then I went to this particular URL, and over here, this is the one.
Okay, these 4 or 6
So,
things.
yeah. So it's very important that you use Dockerfile, okay, for this, because there are lots of things on that install UV, but this particular piece of code is what you need. So just be aware that this is the piece that you need to in order to create your Docker image.
So we also need this particular file in our Docker container, and then we right now what we have Python and we have UV, right? After these two things, what we need so UV doesn't require these dependencies. If this file is there, it can actually run by just typing UV run and then name of the file. So in our Docker file, we just need this TUE underscore app.py, right? So there is a way we can copy any file from our local machine to this Docker container. So I will use copy command, and now I will mention the name of the file and then where we want to um,
Abhijit Kumar, your mic
cop-
is open. Kindly mute yourself.
okay. So what this would do, this would copy TUA underscore dot py should be there. So it will copy this file to the root of your Docker container. So in case if instead of putting it inside root folder, if you want to put it somewhere else, then we can create a working directory. I think it is wkdir. Work dir. So this will create a new folder or repository inside the container. And now I want to copy this file to that folder. And after copying, maybe we can call it app.py, or else we can keep the same name. So now we have Python installed, UV installed, and then we have also copied this particular file. Now the next thing that we want to do is we want to execute this file from container. So for that we'll use this command. So over here I will need to list the commands that needs to be executed. TUE underscore app.py. So this is the Docker file that will build a image. I will just stop the server, and now we will use podman. So before actually I have already configured this podman, but if you want to configure it, then you can go to this installation page, and then if it is Linux machine, since we are working it inside a WSL, so you would need to install, I think, this Debian version, because we have installed Ubuntu. This is the command that we need to execute to install Podman into the system. Once you install Podman, you would have to authenticate it. So there is an easy command to do that. So if I just do Podman login, so it will actually ask me to log in. Since I have already logged in, it will just tell I am already logged in and credentials are there. So now what we will do will now I will actually build this image. So podman build, and I will add a tag to this image to identify it, and we can call it TDS Tuesday. And is there something else? And then we need to put from where we this Dockerfile, where is this Dockerfile is available. So I'm putting dot to indicate current working directory. Okay, there is no Docker file. Okay, it should be small f instead of capital F. So it is first getting the image from Python to install Python, and then it is running these tasks to install think some certification. Okay, it is installing curl. And yeah, now it is installing UV. So once it builds the image, we can look for all the available images by typing podman images. So it tells the repository of that image. So if it is pulled from Docker hub, then it will tell docker.io, and then this is the actual path. So this is the Python image that we have used to build our custom image. So we have used that Python image over here. And then this is our image, which is on local host, and this is the name. So now we have image ID. What we want to do, we want to run a podman container.
So before we had the system running locally on our system. Okay, the server was running on our system. Now what we are going to do is we're going to have the server run from inside the Docker image. Okay, so that's what's going to happen. And you may ask, well, why do we want it to run inside Docker? It's already running on our local system, so why do you want it inside Docker? Can anyone answer that question for me? I mean, apart from the fact that it is required for a project, what's the actual reason? Why do we want it inside? Why do we want the server running inside Docker image, or inside a Docker image? Just open your mic and speak.
For processing the images and translating their text and understanding them.
Sorry, come again, please.
I said just for getting the transcript from the images and understanding and getting meaningful insights from them.
No, that's not the reason. Why do we want a server inside a Docker image?
We do not want any personal changes to affect our image or app. So it maintains a copy of an image. That's it.
Okay. So anyone else? Anyone else has a reason? Can you tell me a reason? Okay, so the reason we have the server running inside a Docker image is because now it becomes distributable, right? You can distribute this server anywhere. It can be deployed anywhere. That's why we run the server inside a Docker image. It doesn't matter if it's a MacBook, it doesn't matter if it's a Windows server, it doesn't matter if it's a Linux server. You can run your server or your service on any system anywhere in the world. So that's why we put it inside a Docker image. A second reason we run it inside a Docker image is if your server crashes, or if it does something that it's not supposed to do, or if it has some issues, only that image gets damaged. It doesn't damage the server or the machine it's running on. It's completely, in that sense, isolated. Now, it's not perfect security, but it is much better than running it on your local system, because our project, if you remember, it'll do all sorts of tasks. It'll be creating files, it'll be modifying files, and the code itself maybe is not being generated by human beings. It will be generated by a machine, and we have no control over what that code is being generated, right? So that's why if you put it inside a Docker image, it can do whatever it wants. As soon as the Docker image is stopped, then it disappears. It doesn't affect your local system at all. So this is the value of putting it inside a Docker image. So that's why we have created this server inside the Docker image. Okay. Right. Okay, carry on, Jivraj. So now next what Jivraj is going to show you is, he's got this image. He's going to run this Docker image. Okay, he's going to, it's like starting a computer. He's going to start a mini server, and it's going to be your server that's going to be running from inside this Docker image. So before, if you remember, he ran it from his local machine and you could access it. So now he's going to show you how to run it, and he will explain how you connect to it, because now it is a separate machine in of itself. Okay, carry on.
And now we need to put the image ID. So it have started the machine, we can say, and after starting the machine, then it will, this machine already have Python and UV installed, but in order to run this command, it will install few dependencies that are there. So now it have install all of this. Let's try to get it. Okay. We won't be able to access it right now. That is because right now I haven't set up a connection. So it is running inside a Docker container, right? But I want to access this port number outside Docker container. So we don't have visibility to this port number outside the container. So for that, we will have to put the port number. I will rerun this image, but this time I will mention the port number. Is it port or dash P? So I will map 8000 of my local machine to 8000 of Docker container, so that now it can send a request from. Okay. So on my local machine, I will keep it 5000, and in Docker, we will keep it 8000. That is because we have 8000 here. Sure. So now let's try to access 5000. It will be because on our local machine it's already 5000. Okay, yes. So now we are able to communicate with the Docker image. And
so are there any questions? What's happened at this point? Is it clear what this command has done? Do you understand what's happening? If you didn't understand, just speak up.
Sir, I don't understand.
Okay. So your Docker is running the server. You understood that, right?
Yes, sir.
Okay. Do you see on the screen where it says UVCon running HTTP 0008000? Do you see that?
Yes, sir.
Okay. Inside your Docker machine, you remember our code said that we are running the server on 8000, correct?
Yes, sir.
Okay. But the 000 is only for the local device that the server is running on. Okay. But now it is not running directly on your local machine. It is running inside a Docker image, which is fully self-contained. It is not visible to anyone else except the applications inside the Docker image. When it was running on your computer, I know right now it's running also on the computer only, but I want you to think about this. Imagine this Docker file is not running on Jivraj's machine. It is running on my machine. Now you imagine. He cannot see this number 0008000. Why? Because it is not on his machine anymore, right? It's running on my machine, right? So only I can see this application, correct? You understood that, right? So
yes, sir.
So Docker is like running it on someone else's machine. You no longer have visibility to what's happening inside that machine. Okay. So the question is, how do you get visibility to what's happening inside Docker? How do you get access to that service that is on port 8000 inside the machine? And the answer to that is, if you look at the code that he's written up there, podman run -p 5000 8000. You see that 5000:8000?
Yes, sir.
So 8000 there is the port that is inside the machine. Which machine? The Docker machine, the Docker image. That is the 8000 that is running inside the Docker image. But on our computer, where we want to access that service, we are saying map all the functions from that internal machine, which is running on 8000, map it to our machine, which is 5000. We want to access it on our browser, our machine at port 5000. So it's a bridge from the Docker to the bridge that is on our local machine. That bridge connection allows us then to connect through port 5000 on our computer. Did you understand that now, how that works?
Yes, sir.
Okay, so that's what it is.
Thank you, sir.
So, so just to condense, you said that 8000 just shows that the particular code is being run on our machinery, and when we use Podman, it converts that 8000 to 5000 and could be used by anyone. Is there something like that?
Okay, I'll just illustrate it. I've done a session on this before actually, but I'll just illustrate it so that it's just a bit easier visually if I show it to you. Just give me 1 second. Yes, Telvin, by the way, you were going to ask something. Is it something related or you want to
Yeah,
add to it?
yeah, I want to add one thing. So
Sure.
here the port has been forwarded, right, to
Yes.
5000, right?
Yes, that's the correct word for it.
Yeah. So I have a doubt. In our project, they have given like 8000 on 8000, right?
Yeah.
So in that case, what will happen?
So that's why I'll show you on the
Yeah.
visually what's happening so that it's a bit more clear.
Yeah.
Okay, is it visible? Okay, so this is the Docker. Oops. This is the Docker image. Okay, your server is running a service. Okay, on this port 8000. Okay, but this is visible only to applications that are inside this machine. You can imagine this machine as a computer, a separate computer. Okay, so if this, say for example, there is this application here that requires a service from this server, then it will only be able to access it via this port 8000, but it's only visible to the applications inside this computer. To give you an example, when it was not running inside Docker, I imagine this was your, initially we had made this computer, right? And we were running it from WSL. So even though we were running actually it's called Tuesday app, right? So even though we were running Tuesday.py and it was running 00008000, right? Even though it was running on 8000, what was the application we were running? We were running a browser, right? But this browser could see that, remember? I will need some auditory cues from you guys to know, make sure you're understanding. Can
Sir, but
you
the
speak?
browser is a part of the machinery itself.
Browser is part of this machine. Okay. So that's why it can access it. Any application can access this 8000 port. Why? Because we have said put it on 000, and 000 means available on the local network. Okay, and where it's accessible to this port 8000. So all applications can access this. But when we put it inside Docker, right, what's happening is we are isolating it. You can think of it as a double wall like this. Okay, we are isolating it from the rest of your machine. For all intentions and purposes, it cannot connect now to it. This is like as if this is a separate machine now. We have packaged it in, we have packaged the server inside a Docker container. The whole point of the container is it's an isolated machine. So whatever it does inside is not going to affect anything that is inside your machine here. It's not going to affect. But also, equally, none of these applications now inside your computer, including your browser, cannot access this machine now, this Docker image. Do you understand the separation now? Hello?
So what is the use for, like, what is the purpose for doing this?
Okay, so the purpose for separating this, okay, is now, I'll give you a good example, okay. The purpose for separating this is now, we now around 1,600 students will submit their application to us, okay. We are going to stick it on our server. Do we know what it's going to do? No, right? Is it safe for
No,
us to run? We don't know. Is there a virus on it? We don't know, right? Is it going to damage our files on the server? We don't know. How do we run it safely? Now, do you see the value
we
in
isolated that.
the value in isolating it? We've isolated it so that it cannot be accessed. It cannot access anything on our system, and we cannot access it directly. But we still need to communicate with it, right? We still need to send it
Yes.
some tasks, because ostensibly I've written this program, okay, and I've told you, hey, run this program, it will do this task for you. You can think of it like outsourcing, right? You're a big defense contractor, you're outsourcing the building of some components to this company, okay. But you want a limited contact. You don't want this outsourced group to have full access to your defense military apparatus, right? You want him to only provide you the service is required, and he needs only access to the things he needs to know, correct? So we need to build a communication bridge between these two, right? A carefully controlled bridge. So that's what we do. We will make a hole here, right? And now I will say this port 8000 that's on the inside, actually I should put it the other way around, but anyway, this port 8000 that's on the inside, I want to communicate only via this port. And on the outside, I've got lots of other things that I'm communicating with. On the outside, I want to communicate via port 5000. So now suddenly your browser, which could not see 8000 before, it could not see this 8000 before. Now the browser via 5000 is able to communicate inside your Docker machine. Did you understand?
Yes, sir.
Okay, so that's what that command does. So when you say podman and you give it the run command and you give it the -p parameter, you tell it, hey, I want to communicate with this Docker container on port 5000. But inside the Docker container, the application itself that I'm communicating with runs on port 8000. So build this bridge for me. So that's why we run that command. We say podman run, it's run, right? Yeah, -p, and we say 5000, 8000, and then of course the image name. Okay, so that's how it works. So it's clear now, I hope, right? So now you're able to run this safely, and you're able to communicate from your browser, which is port. It doesn't have to be 5000. Okay, it could be 8000 also. If you look at the if you look at the specification on TDS for the project, there it says use it 8000 itself. So there it's directly mapped 8000 to 8000. I deliberately asked Jivraj to show you 5000 so that you understand what is actually happening internally, so that you are better able to appreciate the separation that is there between the Docker image and your physical machine. In his case, it's running on his physical machine, but that is that separation, and we bridge that separation using ports to communicate. Okay, carry on, dude.
Okay, now we are running this podman container. Actually, mm, Now if I just do Control C, then it will actually stop that container. And now if I do podman ps, this will get us the information about all the active containers which are running currently. So right now, okay.
So here, Jivraj is showing you something else that is important and a place where many students had issues. So in one of the GAs, if you remember, you had to have a running Docker container in order to submit your GA. Okay, because your container was not running in some cases, your GAs were not succeeding in the checks. Why? Because your application or your podman was not running either on the port that was required or it was not running at all. So how do you check it's running, your server or your pod image? You check it this way. So that is the purpose of checking it this way. And yeah, carry on.
So this will display us all the active podman containers which are running right now. So right now there is nothing that is active because we have finished this particular process. We have shut it down, right? So we have shut down that particular container, or we can call it machine. So now we'll see which all containers were previously running or are running. This minus a, it will list all the containers which were either earlier running or they are right now running. But right now there is nothing that is running. So whatever it will get us will be the older containers, right? So this is one container that is running, and then this is another container. Not right now. We have run it earlier. Actually, this is the one that we run earlier without bridging ports, and then this is the one which we run later with the port connection, right? So now we have this container ID. We can actually restart this stopped container, or this is similar to like we used to shut down our machine by clicking over here, and then it will just shut down our machine. So stopping a container is similar to shutting it down, and you want to restart your machine, not restart, you want to power on your machine, then you can run podman start and then the ID of that particular container. This would restart our container. Right now it doesn't show something like this, so we don't get any information about like it is downloading this or this server is running, right? But if I try to access it through browser, since we are running on the same port 5000, we'll send a request. Oh,
So can someone say why it was not running?
So we use the previous one.
Correct.
It was not.
Correct. We used the previous image, which ran the container, but didn't have a port map to the outside world, right? As in to our machine. So therefore, we cannot access anything inside the podman. So that's a good demonstration. Thank you, Jivraj.
okay. So right now we are running that particular machine. Actually, at the same time, we can run multiple machines. So right now, if I just do podman and then ps, it will show us all the active machines. So this is the one that is running right now. But I won't turn it off. That means I won't shut it down. I will start one more machine. What is the command? Podman start and then container ID. Okay, so now we have started this container which have this bridging. So now it should work. Yeah, it is working. So that's the thing. We can actually create multiple containers and then they can parallelly run. So both of them are running at the same time. And now actually I don't need this container because it doesn't serve my purpose of linking to outer world. So I will just stop this particular container, stop and then container ID. So this machine will shut down. Okay, but we have sent a request to this particular the other machine that is running, which is the other one, this one. But we don't get any information about what is happening in that machine. Whenever I'm trying to access this particular endpoint, earlier it was sending this GET request, and then it was telling if it was a success request or some failure, whatever it is. But right now we don't have any information of that. But there is a way we can get information about um, what is happening within a container. So that is podman logs and then ID of that container. Right? So this is that container. So earlier it have downloaded few things. That is because we had executed UV, right? And then it started the server, and we did not. We executed few commands. After that, we shutted it down, and then we had restarted it. So right now, is it running or server finished? If I send one request over here, and then if I get the log, okay, it's not getting me the log. I think I'm again using wrong container ID. Let me check. Yes, I'm using wrong container ID. That is log of the other machine which we haven't networked. So this displays we have started the machine and then we sent few requests, then we shutted it down. After that we restarted it, and right now it's running. So now if I send one more request, sure.
So if you notice something now, right? These logs are from inside the podman, okay? Inside that machine. So what can it see, right? If you look at the log, can you see the IP address it's coming from? 10.0.2.100. So podman or this image does not, or your server does not know what's happening in the outside world. All it sees is some information is coming via port 8000 to itself, and it's coming from this address 10.0.2.100, which happens to be Jivraj's machine, and it is coming via different port numbers. That's because of the way the network is structured. Okay, so incoming requests are coming, but it's coming into podman. But the important thing here to notice is podman doesn't know what's happening outside. It doesn't know the environment it's in. It is completely isolated from the outside world. So from its point of view, this is what it can see. So do you see this difference? Right? I hope you guys understand what I'm saying. Yeah. Okay. Thanks, Durga. At least someone's giving thumbs up. Others are not so sure. Is it? Okay. Okay. Carry on, Jiva.
Sir, I have a question, sir.
Yeah.
Sir, my friend is running.
Sorry.
Sir, my friend is running a container. Suppose. So how can I access it?
You can't access your friend's container, right? It depends on where the container is running. Unless your friend
No, sir.
builds.
How can I send request to the machine?
So that depends where. So if you're running your friend's container, is that what you're saying?
Sir.
Could you explain it a bit more?
Sir, my friend is running a container.
Okay.
It
Where
is
did he
online. So, sir, how can I send a request to the machine?
To his container or to his machine? To his container is what you're asking. How do you send a request to his container?
Sir.
So for
Yes,
that,
sir.
he has to build a bridge from his container to the outside world, wherever that outside world is. So if it is, so this is where a little bit of networking knowledge will help. Okay, and it's a little bit beyond the scope of us showing it for today's session. But if we have some time, not anytime soon, but say sometime next week or the week after. We can discuss these things in more detail. But that's effectively what happens is, I'll tell you in short what happens. He will have to create first of all a bridge from that Docker that he's running onto his local machine. Then from his local machine, he has to create another bridge, okay, from his machine to the internet, okay. And once that bridge is created on the internet, you also have to open up a firewall port as well. Then once that bridge is created there, then from anywhere in the world you can access the Docker container. So that has to follow a two-step process. So one quick way to get around that is to use Ngrok, which is what is called tunneling, which is making your container accessible via Ngrok. So that is one way to create this bridge. And so now if you look, Jivraj has now opened up an Ngrok app with this container running, and he is going to open it to the outside world. And now any one of you can, as soon as it's ready, will be able to access this Docker that he's running from inside his machine. Okay, so it's running now. Okay, so you see this URL, right? If you guys try this out, right? Try this out. Now we have a double bridge. The first bridge was the Podman, which connects the machine to his local machine to the Docker image. The second bridge he made was using Ngrok to open his local machine to the outside world. And that's what he has pasted in the window for you. So if you access it now from your browser, you should be able to access this very Docker image that he is now currently running on his machine. Yeah, so that's 48,000 to 5,000, and then that's 5,000 to the internet. Right, go ahead. Let's see who's someone's raised hands. Telvin, yeah, go ahead, Telvin.
Just 1 second, sir.
Mm-hmm.
Sir, these connections actually what you are telling, and we need to learn and all like that. Can you put these ones as a small snippets in the what we have discussed earlier is putting in a web space, I mean Google space kind of thing, wherein you can give the links and we will learn through that one by going to that particular website and learning a bit of that one. I mean, to say in the same.
Yeah, we will put some resources for you. It won't be imminent, but it will. We will put some resources. I'll make some. I'll make some notes that you want some resources for it. Okay.
Please, sir. Please, sir.
Okay.
Thanks
I hope it's been useful so far.
No, it is so useful, but the thing is, naturally, after this class, we may forget that one. And if we wanted to tweak the things in a proper manner,
yes.
It would be useful with just more information regarding that one.
Sure.
And tunneling and all like that, I know it very well. And I'm asking you to pipeline the total stream of the information to us in our machine learning language. I've taught you.
Sure.
Thank you, sir.
Okay. Right, I made a note of it. Okay.
Sir, just one thing. While submitting the project, do we have to run? Do we need this Podman Docker images running to into a system?
No, because what we will do is we will pull your Docker image. See, that's why have you pushed Docker image yet? No. Okay, so the next thing we are going to show you is, so we've shown you how to run the Docker image so that you can test your application. But next step now we're going to show you is we're going to push this Docker image to a repository, okay, called Docker Hub. We will show you how to pull it from there. So what will happen is when you submit it there and you will fill up a form for your project, you will give us the URL of where your Docker image is hosted so that you don't have to keep running your Docker image. What we will do is we'll take a copy of your Docker image from the repository where it is kept. We will run it on our server and we will test it out. So you don't have to keep your Docker images running. Okay. Kelvin, you have another question or?
Yeah, so I had a question. So here we are exposing 5,000 port, right?
Yes.
Like, okay. So in my case, my WSL is using 8,000 port.
Yes.
And I am exposing my app in 8,000 port.
Yeah.
So it's not running. So in that case, how will I test it out?
It's not running, is it?
Yeah.
We'll have to see what command you're running. I'm not sure if you've run the command correctly.
No, I took the solution and I shut down my WSL and I ran some local only. It was, but I am asking. So in the project, it's mentioned 8,000, 8,000 he had used.
Correct.
So that's it. Just want to get it clear.
I mean, if you run the command exactly as we told you, right, it should work. You will be able to access it on your local machine.
Okay.
Yeah. Just make sure the order of the numbers are correct. Okay. The first number is the local machine, as in the machine you want to access from. The second number is the number of the Docker machine. So the port that the Docker server is running on. So just make sure the
both
order
we are using 8,000. That case.
If you use both 8,000, then you will have no issue. You can still access it. The only time you will have a problem, is if that port is being used by something else already. Then you will have a problem. So if there is some other service running on your computer somewhere that is using 8,000, then you will have an issue.
So by default, WSL will use 8,000, right? Well done.
There's no such default. It is just something we have chosen arbitrarily. We can change it to anything else. You know, we could make it 8001 or any other port, whatever you like. But the only thing is, for the sake of project, we require you to run it on 8,000. As in, your code should at least run it on. You can test your code on any other number. Okay, if you want to run it on 10,000, I think the maximum is like 65,000 or something. Okay, you can run it on any port number you want that's not occupied on a machine. But before submitting your code and packaging it as a Docker image, make sure that you change it back to 8,000, because we will test on 8,000.
Okay. Could you show like which port which is actually running in 8,000 port?
Yeah, there is a command you can run on your system. It depends on your if you're running in Windows or if you're running in WSL. Both those have different sets of commands to check what ports are currently being used. So Jivraj is typing it for you now on the screen. So if you can use netstat is one of them, I think, or SS also is another one. I think the options are the wrong ones there. Check ports. So netstat, you would use netstat dash tulnp. So the T stands for TCP connections, U stands for UDP connections, L stands for listening ports. So that tells you all the ports that are currently listening. So listening means an application is waiting for some information to come on those ports.
Okay.
So you can see over here, right, what all ports are being listened on. So one you can see is 53. 53 is typically used for, I believe it is email. I'm not entirely sure. Then there is a way to look what these ports are commonly used for as well. So if you look commonly used ports. Yeah. So okay, DNS. So domain name server. So whenever you type something in your browser, right? If you type google.com, that's a domain name. But your machine doesn't know where to go for google.com. What is the number of google.com? So it looks up a server to tell the address of google.com. So it sends that request on port 53. So that is what port 53 is. Okay. So like that, there are other ports that are in use. You can look them up, what ports on your computer are open. And incidentally, this is a good way to find if something nefarious is going on in your computer. If there's some application that's misbehaving or something, and you don't recognize why these ports are being used, that's a good indication that there is some application that's doing some dodgy stuff on your computer, or it's opened up a port that you're not aware of.
Sir, so can we get back to the project? Like
yes, yeah. Okay. So the next step is now we are going to create. We're going to push the Podman image to the Docker Hub, okay? Because this is required for your project.
So for pushing a local image to Docker Hub, I will need username. I don't remember my username. Sign in. Let me create a repo, and what should be the name of repo?
Use TDS
TDS TUE, and let's create the repo and let's keep it public for now. So once we get it, we can actually copy this particular piece of code and I can paste it. So Podman and Docker, they are both command line tools and they work exactly same. All those commands which are available for Docker are available for Podman as well. And what is this tag one? Actually, let us say you want to create versions of your application. So this is how you can do. You can keep v1 for the first version of your application and then v2 for second version of your application, and then that particular version can be pulled using Docker pull. Image not known. Graduate in TDS. Image not known. Okay, let me ask GPT. Did I configure it? That is why. So this problem is because we are telling I need to push to this particular repo, but we are not telling which particular image we want to push. So let me list down all the images. This is the image that we want to push. So I don't exactly know the code. So we would, if the image exists has a different name, then we'll need to use this. Okay, so we need this command. Image ID. Oh, that was very fast. Did it push it? I want to push. Let's have a look at Docker images. We have this image. I think we need to put to Docker IO over here. Then maybe it will push to Docker instead of localhost. I want to push a
I'll paste it in the window.
Oh, right now I have just tagged it, so I will have to push it. Image ID, and we have tagged it. So now let me push this image. Oddman images. So we have Docker IO and then Jivraj and then our TDS TUE and version 1. So let's push this image. Existing. Let's check if it have pushed. Yeah, now we have pushed this image, and now if I look at the version 1 and this is the version of image, and we can actually pull this image back to our system. I think we need to put let me try pulling it. So right now we have these images. So podman pull, and then name of the image is, it is from Docker Hub, and then username is Jivraj18, and now tds-view is the name of that image, and I want a version 1 from it.
Better delete that. Otherwise you'll get confused about somewhere.
So before we pull it again, we actually have the same image, this particular image. So we will delete this particular image so that there is no confusion. I think we can delete these two images because they have same image ID anyway. Podman, RMI, and I will have to use image ID. Unable to delete this because by ID with more than one tag. Please force removal. -F. So now all those 3 images have been deleted. This is the Python image that we had installed. So now I will pull the image from Docker Hub. Invalid use.
Why are we giving like tag name?
We are giving tag name so that if there is this version 1, you have multiple version of your images, right? So you can pull a particular version from there. I have already logged in, so why it is asking for credentials again? Antifraj 18 is the username. Yes, this is correct. Just log in docker.iu. Ensure you log out first and then you log in again and retry.
Okay, while Jivraj is sorting that out, the next thing I want to mention is that you should, in the Google form, so I'll just share my screen meanwhile while he's getting that sorted out. Share screen. Okay, so in in the project page, am I audible? Hello? Hello?
Yes, sir, you are audible.
Yeah. Okay. So in the project page, many people miss this. Okay, they ask, where do I submit my project, or how do I send project? It's under deliverables. There is this line here that says submit in this Google form, and in this Google form is where you submit your project. There is this is the how you get your project evaluated. You must submit this form, and you put your GitHub repo name over here, and you put your Docker image name over here. So it should be in this form, okay? Username / image name. So don't put whole Docker IO / this, that. No, just put username / image name. So whatever your username is and the name of your image. So put that in here. We will parse it from our end. On our server, we'll automatically run a script that will be looking for these 2 things, okay? So just remember to do that. And the next thing, if we are not able to, so the pulling part is just to see if you are able to pull the image of the Docker image. So it's not important from the project point of view, it doesn't matter. But what does matter is you should push your image onto Docker, okay? And push your code, commit and push your code onto GitHub, okay? The next step is we're going to develop the server image that we have now, because it responds to endpoints, and we will try and show you how to do this first task. Now this first task is very important because this first task produces this, fetches this file called datagen.py. Now some of you may think, okay, if my project cannot run without this datagen.py, I'll just sneakily just get this ahead of time and run it and do it. The reason why that's not going to work for you is because this file will be changed when it comes time to running the actual evaluation. So there's no point in hard coding this. Instead, what you ought to do is, and we will show you how to do this now shortly, you will send this request, whatever this request, this kind of request, that will come through your task endpoint, which is this kind of endpoint /read. Then this is a query parameter, right? Question mark path equal to. So to this endpoint, oh, sorry, not read, sorry, run it will be. Okay, it will be a run endpoint. To this endpoint, we will send a task, and the task will be something like this. Install UV and run a script, and it will have this parameter, and that is what will come to your endpoint. Okay, so right now we only had one endpoint which had a /home, right? But now we will have two endpoints which we will show you. One is to read the file, and one is to run a task. So running a task and reading a task. The first task that will be executed is this A1 task. Okay, and don't hard code this task because if you hard code this task, you will fail the project. Instead, we will show you how to parametrically run this task. So that what you need to extract, you need to extract the URL of where the data generation file comes from, because this file will generate all this, the format, .md, dates.txt, contacts.json, all these files, it will randomly generated based on some key. I suspect the key is going to be your user email. That's why you have to provide user email. And once it generates that text, then you can run, then your application will be able to run the other tasks. So that's what we will be showing you next, how to get A1 running. Yes, Sakshi, go ahead.
Sir, actually, I want to ask that the post request does not work on the Google Chrome as it only take get requests. So, is it okay if we check the app with post request on the Postman, and
Yes,
if it is working post on Postman correctly, then it will be working on the project for the assessment?
correct. So in your browser, from the URL, you cannot send a post request. It's not possible to do that. I mean, there are some hacky ways of doing it, but that's not how this URL works. Okay. Anytime you enter something here, right, it's always going to be a GET request. But when you send a form or when you send some data to an application, then the application that is running in your browser, that sends a post request. Okay, but when you type something in the URL, you cannot send a post request in the URL. It's just not possible to do that. You either have to use inspect tools and do it that way, or through console, or through a form, or some other way, but not through a URL. It's not possible to do that. Okay, and the whole reason why he's put a parameterized query there is to make you aware that you can't do it that way. Okay, so that's not the way to solve it. You cannot solve it by putting a post request in your browser. You have to use either a API client like Thunder client or Postman, or you can, if you want, you can even send write a program that sends a post request also. So you can send some headers and things along. So you can write a little Python program that sends requests. Either way is fine. Easiest way is, of course, through Thunder client or Postman. Okay. Students, you ready? No? Okay. Okay. Instead of showing you how to pull from Postman, he will now just demonstrate how to create the task.
Read and task.
TDS. So we'll create another get method for getting data from a file. So it should be read and it will get a parameter file path, and that will be named as path. So we'll put path over here and then a string over here. So this will get us all the URL encoded parameters. So if we have question mark over here and then we put anything here, for example q, and then equal to 1.json or something, then it will read this q variable if I have a q over here. So now what we want to do, we want to read this file. So for reading this file, I want to open this file with open, and we want to open this path file, and we want to open it in readable mode. Okay, so and after that we also need to return, we want return f dot read. So this will get us all the content of that file.
Jivraj, you have to, yeah.
As file I will have to read, and I will have to put it inside a try block. In case if this particular file doesn't exist, then it should raise some exception. So I'll put it inside a try block. If it is successful, then it won't do anything, and then exception as e, and now I will raise an exception. Okay.
You lost your voice.
Wait a second, I'm not seeing something. So how do you raise an exception in fast API? So let's continue reading. I think handling errors is this one. So we'll need to use HTTP exception. And we'll raise it like this. So status code would be 404. That is because this particular file doesn't exist. And details, we can tell that file did not exist. File does not exist. Okay, so now we have created this particular endpoint. I will just execute this file using UV on my local machine. Otherwise, what I would have to do, I would have to create the image again, and then we'll have to run that image. TUE app, and this is running on 8000. Is it still running? Oh, okay. I know I have shut it down. And now we want to go to read. Then we want path to be random.json. So this particular file doesn't exist on my machine. So it says file doesn't exist, and it would get in response, it will have status code 404, right? So if there is some file, for example, let's try to read this Docker file. I will tell Docker file. So now it gets the content of that particular file. So these tasks, what they need to require us to do, they want, for example, this need us to sort something, and then we need to write the result to this particular file. So whenever you do perform this task, at the end it will read through this file if whatever you have done is correct or not. This is to validate. So this read must be there in your application, and then I will make a post request. This is to execute any task. We need run function, and we want to pass this task as query parameter. So the way to read query parameter is we just put it within function. So let's call it task runner, and it should be task, and data type is string. Now whenever we get a task, what we want to do, we want to actually see, these are the two things that we had to do regarding reading. So we have now we want to, we'll get this task as an English sentence, and then we'll have to execute it on our machine. So now we'll send OpenAI to write code for us, right? So for that we'll use request library, which we have already imported, and I will need to import it. And after importing, we'll need to send a request to OpenAI chat completions, and then we also need to pass headers where we have token, and then we need to pass the actual JSON data which have prompt and what task needs to run, and then the response format. And I will store response and response. So what is the URL that we want to use? URL we want to use is chat completions URL. So during week 3, I have seen a lot of students have made a common mistake. They have used either OpenAI's Python module, or they have used some other URL for sending request to, but we need to use this particular URL, which have AI proxy.s Anand. So this is from Anand sir's proxy. And I will define headers now. It should be content type. Application JSON. And then authorization. And this should be the token. And over here, it should be AI proxy underscore token. And this token you can get by going to this particular URL. And if you will sign in, then you will get a token which you can use. So now actually we don't have visibility to this particular token at the moment. So we need to get this token from the system. So AIPROXY underscore TOKN is equal to, I will use OS module to get this token from the environment. Get env and the name of the token AIPROXY underscore token. So I am keeping this name because when they will be running Podman, within Podman we will be able to access AI underscore proxy. So this is the name that must be there. If there is some other name for the environment variable, then it won't work. Okay. Now we need to create data is equal to model. We are going to use GPT-4 mini. And then we need to send messages. And then there will be 2 messages. User, and user will provide task. And actually GPT doesn't know about what we how that particular task needs to be executed. So that's what we have to tell. So we will be having 2 functions. One is script runner, and then the other one is task runner. So what a script runner would do, okay, for now we'll just focus on the first task.
So the reason why there are 2 primary tasks, as I would call them, is because if you look at the way project is designed, project has a single script that will run in the beginning, and it's an important task. And then the rest are just various kinds of tasks that need to be done, right? So the first task is a data generation task. The other tasks are either reading or they are running various tasks that the user gives. So this is by no means the only approach to do it. You can choose any other approach, but we decided to use this approach because it is just simpler to demonstrate for you the separation between these 2 tasks. Of course, you can, again, like I said, there is no one way to do it all. You might come up with a better way or a simpler way, but we thought this might serve the purpose well. So that's why we have 2 tasks, or sorry, 2 functions in particular that we will run. One is called script runner, and the whole point of script runner is to install a package and run a script from a URL with some provided arguments. So if you looked at the tools in data science, the website with the project, you see task A1, and task A1, you basically what it is, it needs to pick up a file, right? It needs to pick up a script, and it is from a location. So one of the parameters that we have to give to it is a script URL, and the other one is the arguments for the script. So in this case, there is only one argument, but this can be a well-defined function. We don't have to necessarily have GPT write code for us to run this script, right? To pick up where the script is from and what the argument is. We don't need GPT to create code to run it, but we do need GPT to parse the task itself, as in extract the URL and the user email from this task that the user has given us. So that's the first task, the script runner we call it, because we are going to take the script and run the script. The second function that we will run is called a task runner. So these are all the other tasks that will be running, which are from A2 onwards. So that will be handled by task runner. So how does GPT decide that is what is Devraj is going to demonstrate for you.
So I will put the prompt. You are an assistant who has to do a variety of tasks. If your task involves running a script, and if you want to run some other task other than running a script and downloading some data, then we'll use task runner. So we'll now define the definition of those two functions. This function and then the actual function definition. So this function calling we have done in one of the session on 31st January. We had a long session, so that's why I won't explain each and every steps. So I will just give the definition of this particular function, what it's supposed to do. So it will install a package. And it need to run a script from a URL with provided arguments. And the parameters that function takes are Oh, it needs to be part of function itself. And these are the properties.
Package name.
So and the type of this particular parameter will be string, and then we'll provide the description about it, the name of the package to install, leave empty if installation is not required. And then the other, okay, we actually don't need the name of the package. Maybe we'll just keep a script URL, and then type would be a string, and description would be the URL of the script to run. And this will contain the arguments. So this is the Python function that we actually want to execute. Now I will send a request to OpenAI, and we need some task. We have this data, and then we need to also mention the functions. And then tools choice. Automatically pick one tool. one response dot JSON. So now I will have to get the. So now I'm just exporting.
Stop sharing the screen.
I know. No, that is just because I want to export the variable, right? So I will be running it from here. So now I have exported the variable. So now I will execute the file. And uv run app.py. Oh, what happened to app.py? Oh, it is cd and cd TDS Jan and then project one and then subdirectory uv run due app.py. And let's go to this Dockerfile. Yeah, we are able to read it. Now we need to send a post request. That's why I will use VS Code. HTTP -127 localhost /8000 and then / it is run and then it should be colon and then it is run and then task is equal to, we'll provide the task till here.
To give it an email.
And I will have to parameterize it. Study.id m.ac.in. Even if I send this request now, it won't get the request because module object is not callable. Let me send one more request. Okay, it's still getting some error and module object is not callable. Earlier it was not saved. So. Oh, it should be request.post. 64. Oh man. Yay! So now it identifies this is the URL where request needs to go, and these are the parameters. So from this JSON object, we can actually get this function name and then arguments. So it should be choices. And within choices, it should be choices of 0 because it's a list. And then it is message, or is it messages? And from message, we have tool calls. And then from here, we need function. And let's return this. Oh, server error. And must be integer or not string. List indices must be integers or slices, not string. Okay, now we are getting these two parameters and the name of the function and then the arguments that needs to be passed through the function.
So I hope you can see that this particular LLM that request that we send, GPT request that we send, when it receives the task, is able to extract the URL, this function it needs to call, because remember there's a task runner and there's a script runner function, and it is able to identify that yes, it needs to use the script runner function, and it also is able to get the arguments of the function. So in this case, it will be the email. So once you're able to extract that out, you pass those, first of all, you select the function to run. So there will be a block, an if block that you will run next. And then you will tell it, okay, this is the URL, that is one of the arguments you pass. And you also pass to that function a second argument, which is that email address that you require. Then we will run the script runner function in order to fetch the file that is required, which is datagen in this case, and it will use UV to run that datagen.py, which will then generate the files that are required to run the rest of the tasks. Any questions so far? So I know that was a bit quick, this section, but we want to try and get you to A1 as quickly as possible.
I have a question.
Okay, go ahead.
Yeah. So here it's script run, right? And we are defining like script to be running from the URL. So if we give a similar wordings and give an prompt, will it automatically pick this prompt script runner?
Yes. So yeah. So the whole purpose of using this function call, as it were, script runner, is so that it's able to parse out the package name that we want. I mean, not package name, the URL of the where the script is, and to parse the arguments that go into it. So those are the two things that are required from task A1, right? If you remember correctly, task A1 has two parts to it. There's a script, a location of a script, and a single parameter that passes to it. Of course, here we take more than one parameter. We can take multiple parameters as well. So it's a little more general, this script, but it's able, the fact that it's able to get the script URL and the arguments that go to it, that's what we need, right? Then once we use that, then the next thing is to use sub process and run UV with that script location and the argument that you want to send to it. So that's what Jivraj will demonstrate next. Is it clear?
Oh, yeah, fine. Can you show me that post request once?
Yeah, okay.
So from this particular thing, we need to get the arguments which have this particular script, and then the argument we need to use. We need to import JSON because this is a string that we are returning. And I will do JSON loads. And then I will get the arguments from it. And within this argument, we need a script URL. But let's first save arguments. And then we need a script URL. And then we also need email. So email is the first argument. So I will just use arguments of arguments. Okay, we have arguments. Then we need arguments of args of 0, which have email. And then we need to, so now what I will be doing, I will be importing sub-process module, and using sub-process we will execute a UV command. So the command that we need to execute is UV and then run, and after that we need to provide the name of that particular script. So this is a script URL, and then it will have email. So this is what we need to run, but we won't be able to execute it directly from this file. So for that, we'll need to import sub process. And now we will run a command from sub process. So this is command that we need to run, and let's run this command. And let's do it inside the container. So I will rebuild the image. Podman, these are the existing images that we have. And podman build -t task runner, we can call it, and then we'll build it from the current working directory. So after it have built, I will run this particular image, podman run, and then we want to access AI proxy environment variable inside Docker. So we'll have to so this AI proxy right now is sitting within our machine, so it doesn't have Docker machine doesn't have access to AI proxy. So this is how we can provide that access. And now I will do port mapping 8000 to 8000, and then we need to put the image ID. Once it does that, so now we have port mapping. We can send the request. Internal server error, and this error is from here. JSON object must be string, bytes, or by not dictionary. Must be string, bytes, or byte array, not a dictionary. Is it already a valid JSON? Let's remove this. And let's stop this particular container. And let me rebuild. Teachers. Take care.
got a spelling mistake. These are two different things. You not see the spelling mistake. The C and the I are interchanged.
So I need to get these commands, but rather than building image every time, what I will do, I will just stop this particular image. So right now I'm just shutting down this machine. So it should not be running. Now I will get inside that machine, and then I will just update the script. So it is exec, and then I think -it, then the container ID. So this will list all the container IDs which were previously running. So this was the latest one that we have created. And now we want to use podman exec -it and container ID, the container which I want to go to, and then this should be bash. Okay, maybe bin bash.
No, you're not running any containers. The containers have stopped running.
I thought it will restart the container by itself, but I will have to manually start it. Now after starting, let's get inside that container. We have this particular file, and we want to, I want to just change content of this file, but right now VI is not available. So we can install VI editor. So VI is just a kind of text editor which we can use. So these are the 4 lines that I want to change. And SCI RPT. SCIRPT. Okay, let's save this file and exit out of this container, and let me stop this machine so that we can restart it and server will get redeployed. Stop and then container ID.
So what Jivraj just quickly showed here is if you have a small error that you want to correct and you don't want to rebuild the image over again and again, you can run a small text editor inside your Docker image. And so that's what he did here. Because if you remember, Docker image is like a separate computer almost, right? So he installed Vim, and then he just made the small, so there's a spelling mistake in his code over there, which is why he's getting the errors. So instead of rebuilding it, he has just corrected it inside the Docker image itself. Okay, hope you understood what he did just now.
Let's restart the container. And I think now we can send a request. And it gets us some error, but let's list down those errors. Okay, I don't know why this is getting some error. It is some indices thing. Maybe we'll continue this session in the next session.
Okay, thanks, Jivraj. Just it's just what you call for it, some JSON parsing, right? So that hopefully you guys should be able to do easily. I think because it's been a long session and we've been working all day as well. So and then at the end of it, we had a 3-hour session. So that's why I think we have reached the limits of our ability to see spelling mistakes and things of that sort. Okay, so we do apologize for that. But hopefully we've got you to the point where you can run. Have you shown UV run for the? Okay, so sub process has been done. Okay, yes, Telvin, go ahead. Yeah.
So I have seen that script. I have a doubt. So here we have like cloning, getting the image from the Docker and running in the container, right?
Yeah.
Yeah.
So actually, the code we are edited in local and we did not push it to Git itself, right?
Yeah, that is true. I mean, ideally, you should not do that. Okay. In this particular situation, what happened is we were just a little bit impatient and wanted to get to the end of the session. So that's why we were doing shortcuts and trying to correct the code. But yes, you're right. Do all the debugging first, and in the end only create the Docker image and then push it once you know it's working.
Okay. Because when I tried, I created an actions class with the workflow where we'll be pushing to the gate and automatically it will be building the image itself in the.
Yeah, that is good. That is a very good approach, actually. That's fantastic approach. That's really good.
And this script will be shared with us, or
this particular script won't be shared because it's just generally been our practice where we don't share what we do. But I hope that you have gained all the knowledge that you need from it, and plus the video will be available. So you can then write out the script yourself. You can always skip ahead and get the bits that you want, right? So you can then reconstruct something that's suitable for your use.
yeah, fine.
Okay. Yes, Sarang. Sarang, go ahead. Yeah.
Hello, sir.
Yes.
Hi, sorry, I was not able to unmute myself.
Okay.
Sir, could you please guide on the B tasks, the B group tasks? What?
Okay. Yeah. So B tasks, if you have a specific question, maybe we can talk about it. But if it is to solve it, then we will have a session on how you can approach those tasks as well.
Yeah. Yeah, the specific question that I have, sir, is that you've mentioned like compress the image or transcribe MP3 file. So those files will also come as part of data gen, or how will those be provided to the script, and
Yeah.
how should the
So
output be shared?
yeah. So what will happen is data gen will create some files. Okay. The current data gen is not going to be the final version of the data gen. Okay.
Right.
So you shouldn't expect the same things to be evaluated or the same files to be created and things of that sort. But in B tasks, what will happen is a clear prompt will be given. The prompt will be similar to these kinds of prompts where there will be a path name and there'll be a file name. All these things will be there. It will be a clear prompt actually, because we have discussed this with Anand about what students can expect so that some little more clarity is available. So he said the prompt will be very clear. It will specify the file name or that has to be worked on and what the task it has to do with that file name. Those two things will be very clear.
Okay, sir. So it's not like we would have to, let's say, some base 64, as a response to the function or something for image.
I mean, so yeah. So over here, compressing and resizing images. I suspect that the task will say, here is this. So this is an example of what could be a task, right? So they get this image from this file, and it could be any number of pillow operations, right? So I don't know what kinds of pillow operations are available, but he has mentioned here that compress or resize.
Compress or resize, yeah.
So these are possible two things that it might need to do. Is he going to give more than that? I'm not certain, I mean, the only thing I can say is that over here, if you look over here, it says, but they have not defined it more precisely than this. So I would take it as this being possibly the limit of what is required, but you could also make it broader. So when we show you a more advanced way of coding, possibly your program might be able to deal with something that goes beyond compressing and resizing, possibly. So yeah, but at the end of the day, I suppose if you can compress or resize an image, then that might be sufficient for visa. I say might because I myself have not seen the final version of evaluate py, which brings me to another point I wanted to make very clear. So I'll just go to this discourse thread. This is quite an important thing actually. So if you all go here, you see this at the top of discourse, there is a link here, right? This is actually quite valuable. If you go here, you can see that there are 3 files. There's a readme, which is this file, but then there's the data.gen py. So evaluate py gets this data.gen py, and you can actually inspect this file, okay? And this will give you some help or clues as to how you might construct functions. Now again, if you rigidly code your functions to do this, then more than likely half your functions will fail because it may not necessarily want you to do precisely this, right? You understand my point?
Yes, sir.
Yeah. But it will give you what? It will give you some help in understanding, okay, this is the kind of function I need to build. Okay.
Yeah, the thing is, sir, we at least, this is very good because we at least have one use case to run against and perfect, all the errors, and then we can make it more general.
Yes, exactly. So you can, that's what you can use this code for. You can use this code to get a sense of, first of all, what kind of tasks it will send. Okay, so if you scroll, okay, so this is the data gen file. This is the file that is being generated. So this is one aspect of it. But if you look at back at here, there's an evaluate. This is a more important file. Okay, the evaluate.py file will have these tasks. So you can see these are the kind of prompts that it will send. Okay. Here's another example of prompts it will send. So these kind of prompts it will send, and it will then run the task, send the task to your run URL, and then it will send one to your read URL. And then it will compare the outputs between the two. Okay.
Okay.
So these 2 files will help you construct your project. But do not use this to hard code against. If you hard code exactly the way it's made, you more than likely more than half your project will fail. Okay.
Understood, sir. Sir, just one more question, sir. Specific one is this for text transcribing.
Yeah.
We should embed the model within this container itself, is it? This faster whisper or something else, or how do you suggest?
Just could you say that again? I didn't quite understand the question.
There is a task for transcribing an MP3 file. I think it's
this one.
B8. Yeah.
Transcribed audio. Yeah. So the way I would approach that is you will get obviously you will get a file, and then you will have to write a code that can run the transcription against that file.
But it will need a model, right, sir? Offline model.
No, it doesn't have to be an offline model. I'll tell you what. Tomorrow we are having a meeting with Anand. I'll clarify that. Okay. Does it can it run using an offline model, or do we use OpenAI itself? Okay, I'll just clarify that. So I'll just make a note of that.
Okay.
1 second. Just stick this on here. Just give me 1 second. It was B8. Okay. Right. Okay. Okay. Any other questions before we wind up
Sir,
the session?
yeah, I know.
No.
There are a couple of more raised hands, so I
Okay.
don't want to take time. But yeah, I just want to, for this making a commit to the Git repo,
Yeah.
we need some Git credentials also, right? And then will those also be provided in the prompt?
There will be public repos it will access, so you will not need credentials.
Okay, so then the code should essentially clone it and then make a commit, but not necessarily sync it, or
So when it clones it, it will just get the, you will run some commands on your CLI, right? That's effectively what will happen. And then once those commands are run on the CLI, then committing also is made on the CLI, right? So you will not need, I don't think you will need any credentials for a public repo. I'm not entirely sure. Do we need for public repo, do we need credentials to make commitments? No, right? We do.
the local commit will happen, sir, but like for the code to be like, again then merged with
Okay,
whatever
okay.
is.
Yeah. I understood. So this is Git repo, right? It says Git repo.
Yeah.
So that
Yeah.
that means not GitHub, right?
GitHub. Okay, got it, sir.
It will be local only. Yeah.
Yes. Got it, sir. Thank you so much.
Yeah.
And yeah, I'll wait for the session on B task, sir. When do you think we are going to have, sir?
We still have to, we have some work that needs to be done before we get that ready. I would say most possibly tomorrow, okay? But I am not 100%
Okay,
sure.
sir.
But if not tomorrow,
Okay.
100% there will be a Thursday session.
Okay, sir.
Okay.
Thank you so much, sir.
Okay. Yes, next, who's next? Sarang, is it?
It was me, sir, Sarang.
Oh, right, sorry, okay.
I'm sir. Sir,
Vanguri? Is it
yeah.
Vanguri?
Yes, sir. Yeah. Thank you. Sir, just now, Jura said that he will be continuing the session in the next term, sir. Please let it happen, sir. Why? Because some of us are directly from data science stream kind of thing. We are not so much techy in this regard. So even though if it is explanation of 10 minutes, that is okay for us.
Yeah,
To
no
follow.
problem. Yeah, this we will continue the session. We are not going to. I mean, not today, obviously, but we will continue next session. We will be continuing to develop this skeleton project that we are doing, showing you.
Yes, sir. Thank you. That's all. Sir. Thank you.
Yeah. Okay. Yeah.
Sir, I was next in line. Sir, the
Vikram, is it?
project criteria. Yes, sir. Yes, Vikram. Sir, the project criteria says you must complete all these 3 steps to get us. So, sir, we have to be able to finish all A1 to A10 to get the complete score, or if some of them are not working in between, uh, I just wanted to be, I just want to understand the criteria there, sir.
What are you referring to? I'm not sure what you're referring to.
I'm referring to the project one. Let
Yes,
me just paste this link in the chat.
I mean, this is project one, right? You can see the screen, right?
Sir, he's talking about the portal.
The portal.
Portal. Let me. Okay, just give me a second. I'll pull up portal. Okay, so yeah, you must complete all these 3 steps. So there are 3 steps here, right?
Oh, these 3. Oh, sorry, sir. I confused this with ABC. Sorry. Okay. I apologize.
Yeah. So you must complete all these 3 steps to get a score. Okay. Which is fill the form, complete the deliverables, and complete the prerequisites. Yeah. So if you look at what the deliverables are, these are all the deliverables. You must complete all the deliverables. We didn't say complete all the tasks, but these you must do. All of these must be done, which is create the repo, add the license. This is why we started from the very first itself. If you were at the beginning of the session, then we showed you how to create these endpoints, post and get endpoints. We showed you how to push code. We showed you how to build the Docker application. We showed you how to publish it and publicly to Docker Hub. Then we showed you how to, so pulling is not necessary, that was just a little bit extra, but publishing it is very important. Being able to make sure that this runs using this token and this construction. By the way, there's an error here in this what you call for it, in this command. You see this $image name, right? That is that should not be there. If you put it here, it will not run. It's an error. So instead of putting it here, I don't know if you can see my marker. Can you see my marker?
Yes, sir, we can.
So this is wrong, okay?
Okay.
This instead should come at the end over here. Okay? This image name has to come at the end. Okay?
Yes.
Okay. We will correct this. I've sent a correction request already. So hopefully it will be corrected by tomorrow. And then the next thing is, yeah, so this is another deliverable, right? So these APIs should be running. And this is a deliverable. You must submit the Google form, right? This form. Essential. If you don't do these, you will get 0. All deliverables have to be provided.
Okay.
Okay. Secondly, these notes are also essential as part of the deliverables. Using AI proxy token in the environment, from the environment. Okay. Obtaining it and sticking to GPT-4o mini. That's the only thing you should use. Okay. And this is something else that is important. Okay, many of you must have skipped past this. I'm telling you now. So since you're in this session, you have gained the value of it. Your each call to any of this. So every task that a call is sent to must complete within 20 seconds. If it does not complete within 20 seconds, if you're doing some very fancy code in the background that's taking 30 seconds or 40 seconds, then you will not get a mark for that task. And complete all these 3 steps. Complete what? Complete all prerequisites in evaluation. So we don't say complete all of evaluation, but these prerequisites are required. Okay.
Okay.
Prerequisites. See, your repository must meet the following criteria to be eligible. Repository exists, publicly accessible. So if it is private, make it public. GitHub repository has a license with MIT. GitHub repository has a valid Docker file. This Docker file must be in your repository. So you remember Jivraj showed you when constructing the Podman, that he showed you there is a Docker file that you have to use to construct the Docker image, right? So that Docker file must be in the GitHub repository. Okay, if it's not there, guess what? You will not be eligible for evaluation. Docker image must be publicly accessible. Docker image should run using this command, and Docker image uses the same Docker file as in your GitHub repository. Okay. These two things are the same.
Thank you, sir. Sir, just one request to the team. Would it be we consider postponing the date of the deadline by some time?
For project?
Yes.
I don't think it will happen for 2 reasons. One, project was released a month ago, and 2, we will be moving the deadline of GA5 anyway. So, so that you can focus on project 1. So that's why I don't think it's going to happen. We will discuss it in tomorrow's meeting, but I would not have high hopes for that.
Kindly, sir.
If I was a betting man, and I'm not, then I would not bet on it being moved.
Okay, sir. Okay, sir. Please.
But
if you get several such requests, kindly consider.
But we will discuss it. I can promise you we'll discuss it, but I cannot promise you it will be moved. Okay.
Okay. Thank you, sir. Thank you, sir.
That's the minimum. That's the best I can do, right? Which is
sure, sir.
Raising it in the meeting. Okay.
Yeah.
Yes.
Thank you, sir. Please at least request this evaluate script, which can be a sample script for tasks B also.
No, when I last spoke to Anand, he's not going to do that. I don't think he's going to provide an evaluate for B. But again, I can always discuss it. I can ask the question.
Okay, sir.
But
Yes.
whether it will come or not, again, I wouldn't bet on it. Because
I understand, sir.
If he creates, evaluate PY is a very good file actually, because it gives you a real sense of what to expect, right?
Yes.
So he's kind of showing his hand if he does it for B tasks, right? Anyway, but I don't know. Maybe he will be kind and decide, okay, it's okay.
Yeah.
So
If you could put a request on behalf of all of us, sir, that would be
I'll
great.
ask the question. Okay.
Yes.
Yes, Telvin.
Yeah. So regarding the task B, right, we have right B3 to B10. And in Anand's meeting, could you ask like clarity on what is the input, what is the parameters, and what is the output? Will it be stored in file or something?
So the inputs will be given in the as part of the request itself. What the inputs are, what the
No, I am
file name
asking
is.
whether it's URL or it's a file name.
It might be anything, right? It could be a file name, it could be a URL. We don't know. Your code should be able to handle the location, whatever the location is. So it's better to think of it as a location. The location could be a local file. The location could be a URL.
Okay. And
But
parameters.
I can ask the question just for clarification. I don't know if he'll give clarity on it, but my understanding, so as far as we know, is that it could be. So this is for tasks P3. So
Yeah, because every task it looks like we can have both the cases.
Yeah, of course. Because I mean, particularly if you think of audio files and things like that, it might be local, right, rather than fetching audio file from somewhere. So that's possible. But then equally possible is getting, for example, cloning a GitHub repo is definitely going to be a URL, right?
Yeah.
So
yeah.
Or maybe it's not a URL. Maybe it's a local Git repo from somewhere else. I don't know. But point is, you should think of it as a location. It might be a URL or it might be something local.
Yeah. So I am expecting some brief description on this one, like all the tasks B3 to B10.
Okay.
Because we are unable to understand task. Like
So
fetch data from API, it's just a REST API.
Yeah.
So what should be written? If it's a JSON, should we save it out or what? If it's
so
not
so that I can give you clarity on. The output will also be mentioned in the task, because if you look at task A, right, you can see clearly the structure. There's an input file and there's an output file, right? But that's part of the prompt itself. The prompt itself will be like this.
Yeah. See, in prompt it's showing input file, output file, but the process is in the description, right?
Yeah.
So according to the process, we have to write, right?
So in here, same thing will happen. A prompt, there will be an input and an output file defined for sure.
Yeah.
That is, otherwise you cannot run the task, right? And you
that's
can't measure
correct.
the task. We can't measure the task also.
Yeah, that's fine. But the parameter we are getting out is that it's a JSON parameter, or should we have an output? That's not defined.
You mean I know what you're talking about. You're talking about this, right?
Yeah, like this. If you want to have an API call, the return type should be a JSON or should be a response.
Yeah,
We
it will have to be this, right? Even if it's a B task. Same thing applies for B tasks.
In B3 task, if you see there, it's giving fetch data from the API.
Sure. Yeah, and save it, right? So
Yeah,
if it
save it.
completes, so if it completes the task successfully, you have to return a HTTP 200 OK response.
Yeah, that I understand. I'm asking that API endpoint is same as our run endpoint. Just consider.
I didn't understand your question.
The API endpoint is 8,000, and we are calling this this post, right?
Yeah.
This itself can be given as an API input, right?
The API input will be the input will come here in task.
Okay.
Yeah, that's what Jivraj was showing you, right?
Yeah.
He basically took this whole thing.
That's fine. That's prompt.
Yeah. He took this
fine.
whole thing and he fed it into here.
That has been taken, and it will be giving a response of 200 or some response.
These are the responses that are expected.
Yeah. So like this response should be there for like B3 tasks also. B3 tasks.
Yeah. These are universal. A or
No,
B.
this is running, right? Running the task you are telling. I'm telling in the task itself they are given fetch data from the task. In B3, if you see, fetch data from an API.
Yeah, fetch data from an API. So what will happen is the task will say fetch data from, and for an example, I don't know, I'm just giving a example, okay, like Pokemon API or something, right? So it'll say, so the task will be fetch data from this API, okay?
Okay.
That's what the task
So
might say,
yeah.
right?
So return type would be JSON or the response I am asking.
The return type. So the return type is, so it says fetch data, but
Yeah.
the data is being fetched and being saved, right?
Yeah.
It is
What
not.
would we save?
No.
Is it a response or a JSON data? That's not different, right?
Whatever you get from the API, does an API normally give you? API will give you JSON, right?
Yeah.
So
No. The response we have, right? Basic response we have. Inside the response we have the data.
I think he is asking response status or a content.
Yeah, that's what. Content or full response itself. That's not the clarity. Its clarity is not there.
Okay, in that sense, that might depend on the prompt itself that's given. I don't know what he will want to fetch from the API.
Because the here everything is broader and we can think anyway. So it's
True,
not
true.
being.
But that's why I said you can't hard code these functions. If your functions are very hard coded, right, it will fail these tasks because that's why they are vague. So it could be fetch data from an API, but it might be so the response or the fetch command might say fetch this key, okay, from this API. It could be that, right?
Yeah, that's what I
So,
wanted to know
so
what's the parameter.
yeah, so we don't know, right, what the
Yeah.
parameters are.
No, if you could ask Anandon that clarity on what, because
Okay.
each and every task we can imagine anyways.
Okay. Yeah,
At
yeah.
least some clarity should be there, right?
But you're asking specifically for B3, right?
No, each and every task needs like same. For clone repo, like we can clone
This
it
is
and we can
straightforward.
we can commit it in local and we can push it also. That's what the actual commit is.
Yeah.
So get the clarity out.
So this is straightforward, right? This doesn't.
No, if you want to push it to GitHub, again we have to have a password and username.
No, it won't. It won't be. This won't be GitHub. This will be to Git only. Clone a Git repo and make a commit. I'll check though, but I'm pretty sure it won't.
Yeah,
Because see,
it's
you
a
need
node repo.
credentials, right? You need
Yeah,
credentials.
that's fine.
So I
And
doubt he
for
will put credentials in the task itself. I doubt he will submit
no,
the credentials.
while running the task, it will be having a prompt where it will ask the credential. Then we will enter, then it will be commit. That's what the intermediate step is.
Yeah, but I don't think he will make it that complex. That would be very cruel and unusual.
Yeah, and for the B5 task, it's telling run and escalate query.
Yeah, that's
And
fine, right?
yeah,
Run and escalate. Yeah.
DuckDB. So DuckDB is an optional or what
Yeah,
we
what he's trying to say is you don't know what database it's going to be, but you'll have to run a query on some database.
Yeah, run a query means it will be given a prompt to be a query itself, right?
Yeah, I mean, again, it's not specific, right? So it could say run an SQL query on either of these databases. So I don't know if
No,
the prompt will be a precise SQL query, or
or
it will
the
say,
update.
or it will be a text that says, find me all the gold tickets that were sold
Yeah,
in.
that's what as
And
it
then
and ask it.
it will have to construct a query to fetch that information from a database, right? That would be the workflow. So
Yeah,
I don't
that's
know
what.
what it could be.
Yeah, so that one. And scrap data from the website is, should we have an tag name based scrapping or should we have an saved it into the CSV like that?
All that will be provided by the prompt. It won't be specified here.
Okay.
What you do with what you are supposed to do, the prompt will be detailed.
Okay, fine. Okay.
See,
And
I understand why you're asking these questions, because to a certain extent you feel you can create a function that will be able to solve the problem, right? And I'm saying maybe there is a better way. Maybe you get LLM to write you the code from a prompt.
Yeah.
Right?
Yeah. Yeah. Understood.
So then you don't have
And
to worry about it, right?
yeah, correct. That's
Yeah.
what.
Yeah. Okay. Okay. Next.
And B8 task MP3 file is there, right? Cannot we try it like online models and try to transcribe it?
I'm see what he has given is he said only to use 4.0 mini. So I have to
No, still
Am I
because
not audible?
hello.
Hello, am I audible?
Yeah.
Hello? Oh, okay.
Yeah. So BA task like we have Whisper model, so we
Hmm.
have different models, right? So here
Yeah.
we
I'll
cannot.
clarify.
Yeah, clarify on that one. Okay. And the last one, B10 task, they have given filter the CSV and return the JSON. So filter column name and value will be single values or multiple we will have.
We don't know.
Okay, that is also not that.
Hmm.
Okay. And last question is like API token got limit expired. So
Oh, API token is expired. Okay, yeah, that's one of the things on our agenda to discuss anyway. Yeah.
okay. Yeah. So if you could postpone a little bit project deadline, then it would be easier for me.
Okay. Sorry, who is this? Telvin, is it?
Elvin. Yeah.
Okay, okay. I think I saw your post on Discord.
Yeah, I have stuck for last 3 to 4 days.
Yeah. Okay, okay. Well, that's something we need to discuss as a team. So I can't, I don't know. My gut feeling is that you will get some extra, maybe. Okay, but we will.
Yeah, at least I need just a week because I cannot proceed right.
No, when I say extra, I'm not talking about time. I'm talking about maybe you'll get some extra tokens. I don't know.
Okay.
Okay.
No, even if I get the token on the last minute, I cannot do right.
Yeah. Last minute, no. But if we are going to do it, you will know by tomorrow for sure.
Okay.
Because tomorrow morning we have the meeting.
Yeah. Okay.
Okay. So if it is decided that there is a mechanism to extend credit to you or some specific students or a whole bunch of students, whatever it is, the decision will be made tomorrow morning and it will be immediately available, because it's very trivial for us to increase the budget in the sense from an operational point of view. From a decision point of view, it's a very different thing, because if we say, for example, if we increase everyone's limit by $1, that's roughly 1.38 lakhs. We have to suddenly ask operations, hey, can you spend 1.3 lakhs on TDS students? They will turn around and say, get on your bike, So, but I'm not saying that they won't do it, but obviously someone has to authorize it, and that can take a little teeny bit more time. Okay.
Yeah, and for tracking purpose, you asked, right, for tracking of the amount of costing
Sorry.
happen. Yeah, you asked about the costing, right, for each prompt. So do like larger prompts and stronger prompting cost more?
Yes, because prompts definitely the amount of tokens you use is what it's based on. So the more larger the prompt is, the more it costs. But to give you an idea, right? So far we've constructed I would say 3/4 of project. Okay, so far.
Okay.
Project one, and we have used up what 20p. We have used up 23p. So we have used up less than 1/8 of the total allowance that you guys have.
Okay.
So it is possible. My suggestion is do all the testing in like some Jupyter file or something to test whether your functions work, whether the expected outcome is what you expected to see. Then you compile it all together in a proper Python file and then push it.
Okay.
So you can test things like that, right?
Yeah, we can test it, but still we have to get the prompts.
Yeah.
Digesting.
But if you run the evaluate.py file, it will test all 10 in one go, right?
Yeah.
But that will be very wasteful. So that's what.
So even for initiating that, I need token, right?
Yeah. So anyway, we will discuss that tomorrow, and we will see what can be done. Okay. I expect you will get some more allowance, but the amount is to be decided.
Yeah. And get us a mail on this one. Okay.
Yeah. We will
Announcement
definitely
itself.
send. Definitely will send a mail. Those sort of things we send a mail.
Okay. Yeah. Thanks for the session. Yeah.
Sure. Yes. Next, Maheshwar.
Yeah, related to task A. So once we get the arguments, right, whatever is shown in the previous. So once we get the arguments, then we will get the input file, and as well as we will know in which file we have to write. So again, we have to call LLM to execute that prompt against that data, or we should write some function and based on that.
See, there are different approaches to this. Okay, there is you can either have LLM to create code for you, or you can write functions that are generic and are able to be parameterized. So in the next session, we'll show you a parameterized version, and in fact, you've seen one of it today. Actually, A1 is a parameterized function. The parameter is what the location is and the argument. So in a similar way, you can construct some of the A tasks. I won't say all of the A tasks, but some of the A tasks you can parameterize and construct them. But if you do all of them that way, then it becomes a bit too rigid. So if there is some difference in what's expected, like from the
Right.
task, then you might fail a couple of tasks. See, the way he's going to evaluate, he's told us, is maybe a third of them will be easy. Okay, so maybe 3 or 4 of them you will be able to get away with some hard coded stuff. Then there will be some medium prompts. These will require parameterization, so it has to be a little more flexible. So maybe you will get another 3 more points. Then some hard prompts he will give. So these will need to be really what you call for it, clever code. Okay, but what is clever code? Clever code is getting your LLM to create the code and generate it for you, right? So,
but for example, like dates, right, or sorting one. If I say sort based on first name and then last name,
yeah,
so this can change based on the prompt.
yeah, of course it can change because it's an array of contacts, right? So it could
Right.
be
So
sort
when I
by phone number, or it could be
correct.
sort by
So when I pass this to LLM to generate a code, right, it will give me based on the prompt itself. It will not
yes.
give me. So you are saying that in first place, whenever we are getting arguments, we should ask for code itself and execute that code. Is
That's
that the
probably
approach?
the most useful way, right? Because that's what an assistant does, right? An assistant
Yeah.
is flexible, able to do anything you ask them to do.
Okay, got it.
So, but that requires a higher level of logic in the way you construct it. So we will demonstrate how to write self-correcting code.
Okay.
Okay.
Because I was trying to write functions, and I think that every task I have written a different function.
Okay.
So is that the right approach, or there could be different approach taken?
It may work for some or maybe half the tasks. It's possible to work that way, but by no means.
But if I write a function for each task, right, the function list itself will be huge. So it will be
Yes.
considered as a token, right? So it will be.
Yeah. Of course.
So that is the reason I'm just
Yeah.
checking means what is the right approach to.
Yeah. This is the trade-off. So the trade-off is you can define all the functions, then the function calling is huge, or
Yes.
you can have LLM generate the code.
Okay, got your point. Thank you.
But just LLM generating the code also requires some very careful prompt engineering. So you get some very precise output from it, and you need a error correcting loop. So you need the code, the error it generates. Then then you run the code. If it produces an error, you take the code, the error, and the context, and then rerun it through the LLM. And then you have some limit, say 3 times or 5 times or whatever it is. And so it will keep correcting itself until it gets the answer right. Yeah, that's one possibility.
Got your point. Thank you.
Okay, next, please, Ashish. Yeah.
Hello, am I audible, sir?
Sure.
Yeah, sir. So what I wanted to ask was, is datagen.py the link? Can we hard code it?
Can you hard code it?
Yes, sir. Because
You can hard code it, but when the evaluation is done, right? you will not get the same data gen file anyway. This is only for your for helping you. So if I go back to, what is it? If I this is the one. Yeah. See, you can hard code this. Okay, data gen to test. In order to test your project, you can hard code this, as in that's what we did. We downloaded data gen instead of fetching it all the time and all that sort of thing. We downloaded the data gen file, we run the data gen file, and then we just test against the files it generates. But if you hard code this into your Docker image, right, I can 100% guarantee you will not pass the project. Why? Because the files that will be generated won't be what data gen is currently doing. It will be a completely different data gen. You see what
Yes, sir. No, sir. I'm not saying the data gen file itself, sir. I'm just saying of the link. Can we hardcode the link? Will the link be same for the for data gen?
No, there is no guarantee of it being the same.
So we'll have to get the link as the first input or the first
Correct.
prompt.
Yeah. I mean, that's what Jivraj showed in his session, right? He got it as a parameter. He didn't hard code it, right?
Okay, sir. Understood. Sir.
That's why this session was very important. So you understand how to get out parameters out of a prompt. If you can get parameters out of a prompt, that's wonderful, right?
Yes, sir.
Okay. Yes, Andrew.
Good evening, sir. I just have like I want to discuss. I have like 3 or 4 points. Can I just go through them quickly?
Yeah, sure. Andrew, are you the one who's posted your code on Discourse?
Yeah, yes, sir.
It's pretty good, man. It's I was very impressed.
Yes, I have that also. But first, the self-correcting code you discussed, no, sir. I tried with Crew AI and AutoGen,
Yeah.
like with their code interpreters. But the problem is the model, like it didn't recognize the UV package or the other
Yes.
two packages. Like I think it was like a little bit older model because I think UV was quite recent. Like
Correct.
so that I ran into an issue. I hard coded it. Still, it kept giving UV con and interpreting it. But sometimes, maybe 2 out of 4 times, it gave the right code. But
Yeah.
then that was one issue I had. So, and the other one is today's session, no, sir. I just wanted to know the code link or the like where I could just access it because I wasn't able to attend the session. I might be able to attend the session, so I just wanted to know if I could just get the link.
Yeah, so we will not be providing the code, brother. I'm sorry about that. But we will be uploading the session itself.
Okay, that's no problem. Then in that TDS in this screen sharing, it has the live sessions, right? This option.
Yeah. So we will. So that will come out tomorrow.
Okay, and the other one, the extra credits, no, sir. Those who haven't used their credits, would they also? Because I use the local LLMs to test everything.
Sure. Yeah, that's fine.
Because,
You
but at
can,
the end, when I just wanted to make sure after everything was working, then I would use the AI proxy. So I
that's
just
brilliant. That's brilliant approach. Use local LLM and check everything is working first. Yeah.
yes. So I just wanted to know whether we'd get extra credits for that.
That's up to Anand.
No,
That's all
no,
I
no.
can.
Like if everyone's getting, I don't want to, if everyone's getting $1, I think too much. Maybe 50 cents to 25, 50 cents, little bit extra, just a little bit for testing, like one.
Yeah. So see, that's what tomorrow's morning's. So some students have run out of credits. So tomorrow's morning session, we'll discuss how
That.
much and all those things will be discussed.
And the other one, I just you said we couldn't hard code the functions, but that was I think week 3. That was the main topic, right? Function calling with schemas.
Yes. Yeah.
So I just wanted to just show you some code just to see whether if that is somewhat general or even more general than that. Can I just share my screen?
Okay, Andrew. See, this is not going to be the only session.
Yeah.
We started this session at 5. It's been going on for 4 hours, so we really need to make a hard stop here. Okay. I hope you appreciate that, right? Okay.
Yes, sir. Okay, I'll just join tomorrow. I just wanted to discuss. So I just want to get last point that so how do we basically go about it? I like okay, just if you could just go to task 1 or 2 or 3 or task 9 or A10 in your screen. Yeah. Yeah. See the 10th one, right? A10 could it generally be just query a database? The most general one. So we can get arguments as the database file, the
Yeah.
table name tickets, and the type. I mean the column names and everything could be arguments. But the main thing is just query a database. Would that be general enough? Is what I just wanted to say.
Yeah, yeah. I mean, that sounds fine to me.
Yeah, no, because I'm not clearly sure exactly how general it is. Because if I tried a code interpreter, it doesn't generate the code, and I rerun it 4 5 times. It not hallucinates it. It goes back to the same thing and gives the same output again and again and again
Right, right.
without the context. Even if you use the error code message.
Okay.
So I just want to know how general it should be. So A10 could be just, I don't know, query a database. A8 could be get text from an image.
Right. Okay.
I just want to know.
Yeah. So I'll see Andrew. I really have to make a hard stop. Okay.
Okay. Yes.
Because we are really exhausted here.
Okay.
So we'll take up these questions next session. But
Okay.
put on discourse if you can,
Okay. Okay.
because you just joined, right? We've been
Yeah.
going at it for 4 hours.
Yeah. Yeah.
So just put on discourse these questions. Tomorrow
Okay.
morning before our meeting, I'll have a look at the discourse post and
Okay.
we'll discuss.
Meeting tomorrow. What time? Morning, sir.
Our meeting is at 9:30. So if you post
9:30
before
in the
then,
morning. Yeah. Okay.
yeah.
I'll join.
So what you do is make a detailed,
And yeah, I'll make a detailed report. Like I'll go through everything again now today,
yes,
and
and
I'll.
ask your questions in detail, and then
Yeah.
tag Anand on it, and
Yes.
we'll
Yes.
we'll discuss that in tomorrow's meeting.
Yes. Sir. Thank you.
Okay.
Thank
Thank you, everybody. Thanks. I hope this session was useful for all of you, and thanks for being with us. Whoever has stuck with us from from the beginning of the session. Okay. Thanks. Thanks. Good night.